本日は JAXA 国際宇宙探査シンポジウムです。
Good morning, ladies and gentlemen. Thank you very much for coming to today's JAXA International Space Exploration Symposium 2024. Today's event will begin at 10 o'clock. Before I start, there are some housekeeping notes to you. Smoking is not allowed in this hall. If you wish to smoke, please go to the second floor for smoking area. Restrooms are located outside of the hall. When you exit the place, go to the right-hand side and past the reception desk. You can find the restrooms on your left-hand side. Eating is not permitted in the venue. Beverages may be brought into the venue in containers with lids only. When you take video or photos, please remain seated in your seat. And refrain from posting or publishing your photos on social media or other types of media. This event will begin at 10 o'clock. Thank you for your patience.
本日は JAXA 国際宇宙探査シンポジウム2024
Good morning, ladies and gentlemen. Thank you very much for coming to today's JAXA International Space Exploration Symposium 2024. We will begin the event at 10 o'clock. Thank you for your patience. Please make sure to turn off your smartphone or set it to silent mode. We will begin the event shortly. Thank you.
皆様おはようございます。
Good morning, ladies and gentlemen. Thank you for joining us today at the JAXA Space Exploration Symposium 2024.
新宇宙探査時代にご来場いただきまして誠にありがとうございます。また
Also, for those of you watching this event channel on YouTube, thank you for connecting.
2024年日本の宇宙探査
In January, the smart lander for investigating the moon, SLIM, demonstrated the world's first high-precision landing with an error of less than 100 meters. And in March, an observation instrument proposed by a team led by the University of Tokyo was selected as one of the first instruments to be deployed on the lunar surface under the International Space Exploration Program Artemis project.
公開される最初の観測機器の一つに選定されました。そして4月
And in April, the U.S. National Aeronautics and Space Administration, NASA, and the Japanese government agreed that Japan would provide a crewed pressurized rover for the Artemis program. And Japan is expected to become the second country in the world after the United States to land a man on the moon.
当イベントでは
In this event, we will discuss the concept of Japan's strong international presence and its all-Japan structure of industry, academia, government collaboration to leap toward sustainable exploration and utilization as humanity moves toward full-scale exploration of the moon and Mars.
くれましたが
And my name is
本日司会進行を務めます藤村
Haru Fujimura.
本日は
And I will be the moderator for today's session. Today's session will close at 4 p.m. with breaks in between. I hope you will stay with us throughout the event, though it will be a rather long one.
ありがとうございます。
Thank you very much.
それでは開演に先立ちまして
Upon beginning our session today, on behalf of the organizers,
開発法人宇宙航空研究開発機構
Hiroshi Yamakawa, President of the Japan Aerospace Exploration Agency, JAXA, would like to deliver an opening address.
理事長
President Yamakawa, the floor is yours. Good morning, ladies and gentlemen. My name is Yamakawa, President of JAXA. And thank you to all of you who have joined together this morning from the very early time of the day. The Space Exploration Symposium was held last time, has been held since our first session in 2019. But it is the first time for us to have this kind of in-person session after 2019. So it's the first time in 5 years to meet in person. So I have been looking very much forward to this event. And the moderator has kindly mentioned this, but let me repeat this. But 2024, this year, we will be seeing many developments in Japan's space exploration activities. In 20th of January, the smart lander for investigating the moon, SLIM, was able to actually demonstrate a precision landing of an error within 100 meters, and also withstanding the lunar night, which we call etsuya in Japanese. We were able to succeed in this multiple times. And in April, we were able to sign a historical implementation arrangement between NASA and the Ministry of Education, Culture, Sports, Science, and Technology for the exploration concerning lunar surface exploration using the pressurized rover. So with Japan providing the pressurized rover, it stipulates that Japanese astronauts will be given 2 opportunities to land and engage in activities on the lunar surface. And we will be going forward with a LoopX mission, and also we are aiming to launch the Mars Satellite Exploration Project, MMX, so JAXA's exploration missions are really lined up for the future. And today, with this Symposium 2024, we are looking at efforts of exploring the outer space with the industry, academia, coming together to explore the outer space with an all-Japan team effort. And this aims to increase the momentum for the future. And today we have prominent faces from NASA, the academia, from the Japanese government, and from the business community, which are all essential people for promoting exploration in outer space. And this is a very rich program that we are offering today with a wide range of stakeholders. So I hope that you will stay with us until the end and share your thoughts about the future of Japanese space exploration with all the participants. So thank you very much once again for convening today. Thank you very much. And now we would like to move on to today's keynote speech. The keynote speech will be given by Mr. Masanori Nagai, Deputy Director General for the Research and Development Bureau, Ministry of Education, Culture, Sports, Science, and Technology. So, Mr. Nagai, the floor is yours. Well, I will be talking from this microphone. So my name is Nagai from the Ministry of Education, and as President Yamakawa mentioned up front, this year is a very symbolic year in terms of Japan's space exploration, and we have seen a lot of news on the press, and we know that many people are talking about this, and I am really happy that this kind of a symposium is being held, and I would like to thank all the people who have put in a lot of initiative to organize this event. And I would like to talk about Japan's initiatives in moon exploration and space exploration. And first, I would like to touch upon the recent trends in lunar exploration by various other countries. This is just a summary of the past year. Last year, in August, India succeeded in landing on the moon, and also a U.S. private company also had a project, and China's spacecraft Chang'e was also landing on the moon, and they are also planning for a sample return from the other side of the moon. So we have a lot of lunar exploration missions underway. And as the Japanese government, as we touched upon earlier, this is the Artemis project that is led by NASA, and we will be engaging in lunar exploration under this project. For the details of the Artemis project, we have prominent people from NASA today, so I will leave it to them, and I will not go into details. But simply stated, this is about realizing a sustainable exploration of the moon and set the goal of manned landing on Mars in the 2030s. And also to develop the necessary technology and capabilities to achieve this through sustained activities on the moon. And also we will be constructing the gateway towards the mid-2020s and other activities. And let's look at the Japanese government's initiatives. In 2017, the U.S. president first announced this mission to return to the moon. And in 2019, they have decided on the Space Development Strategy headquarters. And first, we have agreed to have Japanese batteries and other equipments being provided to the gateway, and also providing supplies to the gateway, and also to share the data on the lunar surface with NASA and other entities, and also to provide the pressurized crewed rover in this mission. And we have been discussing with NASA, and if you look at 2022, we have signed the implementation arrangement. So this is an agreement with NASA regarding how we are working on the gateway. And the gateway is a manned space station that is orbiting around the moon, and Japan will be providing life maintenance equipment and other vital devices. And in return, NASA will be providing opportunities for Japanese astronauts to engage in activities at the lunar surface. And in April of this year, we were able to have the agreement on the framework agreement regarding Japan and U.S. space cooperation. And we have this implementation arrangement and the framework agreement put in place, under which Japan will be able to provide the pressurized rover to the U.S., and in return, Japanese astronauts will be given 2 opportunities for engaging in activities at the lunar surface. Japan alone does not have its own means to land man on the moon, so we are collaborating with NASA. And as I put over here, we have this vehicle which has habitational environment where you can move, and you will be able to use this more like a camping car and move along for 30 days consecutively without wearing a spacesuit. And this is a very strong tool for further enhancing lunar surface exploration initiatives. And this will play a very vital role in lunar surface exploration going forward. And we are looking at launching this in 2031. So these are the initiatives that are being undertaken vis-a-vis the Artemis project. And let me also talk a little bit about SLIM. So this is not an original part of the Artemis project, but as you all remember, we were able to succeed in pinpoint landing on a lunar surface in January this year with an error within 100 meters. And actually, we had some engine trouble upon landing, and without that, we were supposed to have been able to make a landing of an error between 10 meters, within 10 meters. And we were also able to succeed in withstanding lunar nights for 3 nights. And the time difference in Japan is very wide, with a high of 100 degrees Celsius and a low of minus 110 degrees Celsius. And so this is a very wide range. And probably the Japanese have said that a rabbit is making mooncakes on the moon, but if there were an actual rabbit on the moon, the rabbit would certainly die with this kind of temperature difference. So we are now looking at why this has become possible, and so we are looking into this in JAXA. So these are the recent trends. And now let's look at what is really underway in terms of Japan's initiatives of lunar exploration in the future. And we are looking at space policies, and as on number 1, there is fierce international competition in this area. And also, there is a game change taking place in the space business. Now we are seeing an entry of more private sector leadership, where formerly this area was typically government-led. And also, the activities in the space are becoming much more active, and we are seeing a lot more launches by other countries for satellites, including the United States and China. And we have more than $400 billion going to more than $1 trillion in investment in this area. So activities from the private sector is also on the rise. And JAXA and the national government and the academia used to be the centerpiece of space exploration, but now more and more people from the private sector are becoming involved in this initiative, so that we will be able to move further forward in space exploration. And so to do so, we have revised and amended the space laws last year. And this expects that JAXA will play a pivotal role, serving as the hub for space exploration. And we have 1 trillion yen of space exploration funds to be established. We are starting with 300 billion yen. And using that, we will be providing funds to the universities and other sectors of the academia to further promote space exploration. And looking at the areas where we will be supporting, we first have the satellite technology, and also space and science exploration and space transportation technologies are the focal points. And we want to enable Japan to be able to autonomously engage in space exploration with its own technology. So that is why we are selecting these areas as the areas of focus. And when it comes to space exploration, we have lunar surface and Mars surface exploration, moon positioning system, and propulsion system technology and other basic technologies will be studied. And lastly, Japan alone will not be able to go forward with promoting lunar and Mars studies. So we do have to work with our international counterparts, including NASA and other entities. And to do so, we need to really focus on the strong points that Japan has to offer. So first, we would like to provide the technologies that are held by Japan's private sector as well as the academia, and to further promote those areas, and to also promote a mood of cooperation and collaboration in the international community. I think this will lead to elevating Japan's presence in this area. And space exploration is also a once-in-a-lifetime opportunity for us as a country. And having Japanese astronauts landing on the lunar surface is also one very significant goal. So we look forward to your continued understanding and collaboration going forward, and we would like to work in tandem with the academia, industry, and other people. Thank you very much, Mr. Nagai. So please give him a good hand of applause once again. Thank you very much.
Now we will change the layout on the stage. So I'd like to ask for your patience. Thank you. Now, we would like to begin part 1, which is titled Overview of the Artemis Program and Japan's Space Exploration Strategy. We have invited the representatives from both NASA and then JAXA to share their activities and efforts. The moderator is Ms. Tomoko Kitagawa, who is the advisor to Senior Vice President of JAXA. Some presentations are made in English, so if you wish to listen to the Japanese interpretation, please use the receiver at your hand. Now over to Kitagawa-san. Thank you.
And welcome to the session, everyone. This is part 1, the overview of the Artemis program and Japan's space exploration strategy. I'm the moderator of this session, Dr. Kate Kitagawa, Senior Counselor for International Relations and Advisor to Senior Vice President. Now, it's my great pleasure to introduce 4 distinguished speakers to the stage. I will call their names, so please come to the stage, the speakers. So the first person is a very distinguished guest from NASA, Ms. Catherine Corner, the Associate Administrator for the Exploration Systems Development Mission Directorate at NASA headquarters. Catherine Corner is responsible for the development of the NASA's Moon to Mars architecture, defining and managing the systems development for Artemis missions, and planning for integrated deep space exploration approach. Thank you very much for coming here today. And Dr. Nicola Fox, the Associate Administrator for the Science Mission Directorate. Dr. Fox directs around 100 NASA missions to explore the secrets of the universe. Missions that use the view from space to assess questions as practical as hurricane formation, as enticing as prospect of lunar resources, as amazing as behavior in weightlessness, and as profound as the origin of the universe. As the associate administrator, Dr. Fox creates a balanced portfolio of carefully chosen missions and research goals to enable a deep scientific understanding of Earth, other planets, the Sun, and the universe. Thank you very much for being here today. So up next, so today we'll be alternating English and Japanese. So we'll be introducing the vice presidents from JAXA. So, 宇宙航空研究開発機構 JAXA より
From JAXA, we have Mayumi Matsuura, the Vice President. Please come onto the stage.
松浦理事をご紹介させていただきます。
Let me introduce Dr. Matsuura. Since 1998, she has been involved in the project for the Konotori and then Japanese experimental module Kibo, and he was served as the flight director. And then since 2016, she was transferred to the current system and then assigned as the project manager for the development. And in 2023, she is the manager for the operations center and the sub-manager of JAXA and the NASA program. And then she became the vice president in April this year. Thank you. And then we have Dr. Hitoshi Kuninaka, the vice president of JAXA and the director general of the Institute of Space and Aeronautical Science. Let me introduce Dr. Kuninaka. He graduated from the Tokyo University and then obtained a PhD degree. And he invented the new engine and then also led the Hayabusa and the Hayabusa 2 programs. And in the Hayabusa 2 project, he served as the project manager. And since 2018, he has been serving as the Director General of the Institute of Space Aerospace Science, and he was awarded the Medal of Honor from the Japanese government, and he became the honorary member of the Space Association of the U.S.
In this session is to make sure that we all have the right equipment. So as this session will be led by English and Japanese, so please, the audience, please get ready to use the earphones for simultaneous interpretation. So 皆さんもう一度ご紹介させてください。このセッションは英語と日本語で
This session will be proceeded both in English and Japanese. And if you have a receiver, please use the earphone to listen to the interpretation. The Japanese language is number channel 1, and then channel 2 is English.
So now we are all here. Let me briefly explain the 3 main goals of this session. So as the title of this session states, the first one is very straightforward. It is an overview of the Artemis project. So it's our hope that all of you here and online will grasp the big picture of how the Artemis campaign has been going and how it will be leading us, where it is leading us to. So we like to really capture the big picture together today. So from the engineering side of developments and together with the scientific research, 2 associate administrators from NASA will give you the concise map of the Artemis campaign. The second goal of this session is to show the past and future milestones related to Japan's partnership with NASA. So what have we done so far, and what shall we do next? Both NASA and JAXA presenters will be giving examples of past and future collaborations. The third goal of this session is to highlight Japan's strategic plans in space. JAXA is evolving with the Artemis campaign. So we would like to show how other missions of JAXA would contribute to the international endeavor of space exploration and to the development of space science and engineering. So 3 things, again, all together: the overview, milestones, and the strategy. Without further ado, I would like to pass the mic to Catherine Corner and Nicola Fox. So please take the stage, and the presentation begins now.
Thank you. Good morning. I am Kathy Kerner, Associate Administrator for NASA's Exploration Systems Development Mission Directorate. Thank you so much for having me here today. It is great to be back in Japan, especially after we have recently publicly announced another incredible partnership with your country, the Pressurized rover.
And I'm Nikki Fox, and so I'm the Associate Administrator for Science, and I'm also extremely excited to be back in Japan. It's really nice to be here with Kathy and the exploration team, highlighting how we're working together, and also to be able to discuss some of the really great science that we do in continued partnership with our JAXA colleagues.
It's somewhat rare that Nikki and I get the opportunity to give a joint presentation, but we're truly 2 sides of the same coin. Without science, exploration lacks purpose. And without exploration, science stands still.
And I'm in complete agreement with you, Kathy. Exploration and science are intertwined with an incredible global community that is really invested in our work.
To begin with, I want to take a moment to address why NASA is taking on this tremendous effort and its value for our stakeholders. NASA explores for 3 reasons: science, national posture, and inspiration. These pillars span the broadest representation of our stakeholders' values. One pillar is inspiration. I think most of us in this room can remember the wonder of being a child and looking up at the stars. Many of us still experience that sense of awe and appreciation when we see things in exploration. The Artemis campaign is inspiring humanity to go further than we ever thought possible, to be curious, to push boundaries, and to achieve the impossible. Together, we're building the next generation of space entrepreneurs and STEM workforce and reminding each other that we are capable of amazing things, things that others can only dream of and imagine. Artemis will continue to inspire by showing the world that NASA and our partners have not only dreamed it, we are doing it. A second pillar is national posture. Artemis comprises many international partners, commercial space partners, and other government agencies that together are making lunar exploration possible. We have long collaboration with Japan on incredible projects like the International Space Stations. Those partnerships have bolstered our country's collective reputations on an international stage and have made incredible contributions to humanity's shared knowledge. We are leading by example, building on what we have already achieved in low Earth orbit and bringing others along who share our vision so that we can ensure that the next steps humanity takes in space will be taken in peace. The final, and arguably the most important, pillar is science. Science drives our exploration missions, and the value of the discoveries we will make is impossible to calculate. Science fuels economic development as well as discovery, and the moon is a rich destination for scientific discovery. Studying and analyzing the lunar environment and samples from the area of the moon where humans have never gone before will unravel some of the greatest mysteries of our solar system for the benefit of all.
And with science as the key pillar of why we explore, it is important to understand the different facets of science that NASA's Moon to Mars plans will actually allow. Every single NASA science division has a stake in Artemis. For efficient use and planning, we've actually grouped the agency's lunar science objectives together. From geology to solar, biological, and fundamental physics phenomena, exploration teaches us about the earliest solar system environment. whether and how the bombardments of nascent worlds influence the emergence of life, how the Earth and Moon formed and evolved, and how volatiles like water and other potential resources were distributed and transported throughout the solar system. Space exploration teaches us about human and plant physiology in extreme environments, how to mitigate engineering and health risks, as well as how to perform complex operations in harsh planetary environments. Space provides a unique vantage point to greatly amplify current learning on Earth. Biological and physical systems can be observed in reduced gravity, bringing out second and third order effects that are otherwise overwhelmed by the gravity environment here on Earth. The history of our sun is preserved in the lunar soil, and so examination of which enables solar activity predictions and space weather forecasts, which in turn supports lunar and Martian exploration. Now, I hope you followed along recently as the first US commercial lunar landing was successfully executed by our industry partners, delivering NASA science and other payloads to the Moon's South Pole region. Our Commercial Lunar Payload Services initiative is one of the ways we're fostering a deep space economy and increasing the types of partners and organizations who can benefit from lunar research. More access to lunar missions and a new way to deliver NASA science payloads with increasing frequency means more opportunities to assess the characteristics, the history, and the makeup of the Moon. We're interested in what planetary bodies throughout our solar system and beyond that are made, what they're made of, because it may reveal how they formed and changes they've undergone through time. Viper is one example of a robotic mission set to be delivered by a commercial lunar payload systems flight, and that will provide scientific data and a technology demonstration to complement experiments that will be done by future human missions. NASA's landing site analysis for Artemis missions is made possible by data gathered on Apollo missions and by uncrewed missions like the Lunar Reconnaissance Orbiter, which has given us so much more information about our Moon than we could ever have imagined. LRO has studied the Moon in unprecedented detail since 2009, including the ways in which its surface has been altered in recent geologic times. LRO has accomplished all of its original science goals and continues to perform science investigations after beginning its 5th extended mission in 2022. LRO's instruments have provided us with some of the best long-term measurements ever made of radiation in deep space and the most accurate topographic map of the Moon to date. LRO also looks for water, particularly focusing on the Moon's poles to search for water ice that could exist in the permanently shadowed craters. And so by using robotics, remote operations, and autonomous technologies in advance of and alongside the human missions, we get the best of both strategies and we maximize the data and samples we can collect and we can analyze.
The Artemis campaign is a series of increasingly complex missions that provide ever-growing capabilities for scientific exploration of the Moon. Together with our partners, NASA is working towards establishing the infrastructure for long-term exploration in lunar orbit and on the lunar surface. The infrastructure will facilitate ongoing scientific research and discovery for the benefit of humanity. Ultimately, what we build, test, and discover at the Moon will determine the human capacity to live and work in deep space for longer periods of time, setting us on a steady path for our next giant leap, Mars. Artemis 1 was our uncrewed flight test of the integrated space launch system and rocket and the Orion spacecraft. Early on November 16th of 2022, we lit up the night sky as we lifted off from NASA's Kennedy Space Center in Florida, flying a beautiful 26-day mission around the Moon, sending Orion further than any spacecraft designed to carry humans and return them safely to Earth has ever gone before. On December 11th, 2022, Orion splashed down in the Pacific Ocean off the coast of Baja, California, where a cross-government team was waiting to recover the spacecraft and bring it back to the United States for analysis. Since returning the vehicle to dry land, we have removed the scientific payloads inside and inspected the capsule, learning all that we can before we fly astronauts on our next mission.
And the payloads and the instruments on Artemis 1 reflected contributions from across the NASA agency, as well as 5 international partners, and partnerships among several universities, industry partners, and other research institutions, and of course, including Japan. The mission taught us a lot about how to integrate payloads with the deep space transportation systems, and this knowledge will help us make sure that we take full advantage of every opportunity on all future Artemis missions. Each payload team had varied levels of success, and we certainly have a lot of lessons learned, all of which help us gain overall knowledge about how to explore the Earth-Moon system through Artemis.
Since the successful test flight of Artemis 1, the agency has been diligently implementing what we learned in preparation for Artemis 2, where NASA's Reed Weissman, Victor Glover, Christina Cook, and the Canadian Space Agency's Jeremy Hansen will venture around the moon. Artemis 2, which is planned for September of 2025, will be a 10-day lunar flyby mission that will test the Orion spacecraft's life support systems to prove the capabilities required for the crew to thrive in deep space. As we prepare to fly, safety is and will continue to be our top priority. We will fly when we are ready.
And on Artemis 2, it will also provide us an opportunity to conduct science and human research. Artemis research for crew health and readiness, or ARCHER, will be worn by crew members to collect data on sleep-wake patterns, activity levels, and performance of operational tasks. A second study, called Immune Biomarkers, will examine samples of the crew's saliva to determine how space travel affects our immune system. And we're also excited for the opportunity to have humans make observations from the cislunar vicinity and the lunar far side for the first time in over 50 years. Artemis 2 will also host experiment payloads dedicated to biological and physical sciences, and we will also release several CubeSats. And the details of all of this will be announced in the coming weeks.
Artemis 3 is planned for September of 2026, and it will mark humanity's first return to the lunar surface in more than 50 years. NASA will make history by sending the first humans, including the first woman, to walk on the moon, to explore the region of the lunar South Pole. SpaceX is providing the human landing system they call Starship that will transport Artemis 3 astronauts from Orion in lunar orbit to the lunar surface and back again. You may have just seen last week that they conducted their 4th integrated flight test of the Starship rocket with some incredible video from different phases of their flight test. The company will fly at least one uncrewed demo mission to land on the lunar surface before it will be ready for its first Artemis mission. Before the crew launches on Artemis 3, SpaceX will launch a storage depot in Earth orbit, and a series of reusable tankers will carry propellant to that storage depot. The uncrewed Starship human landing system will then launch from Earth and orbit and rendezvous with the storage depot to fill its tanks before executing a translunar injection burn and traveling to lunar orbit, where it will wait for the Artemis 3 crew arrival. When both spacecraft have arrived in the near rectilinear halo orbit, or NRHO, Orion will dock with Starship, and while 2 astronauts remain on Orion, 2 will board to head down to the lunar surface. Axiom Space is providing the Artemis 3 surface suits and spacewalk systems that will provide enhanced mobility for conducting science on the lunar surface. During their moonwalks, the astronauts will take pictures and videos and retrieve samples and collect other data to meet specific scientific objectives.
And NASA's Planetary Science Division recently worked with their human spaceflight colleagues to select for further development the first science instruments designed for astronauts to deploy on the surface of the moon during Artemis 3. One instrument, the Lunar Dielectric Analyzer, is being provided by the University of Tokyo and funded by JAXA. Once installed near the lunar South Pole, this instrument, along with another 2, will collect valuable scientific data about the lunar environment, the lunar interior, and how to sustain a long-duration human presence on the moon, which, of course, will help us prepare NASA to send astronauts onto Mars. What we learn from the new lunar samples will help us understand the makeup of our moon, the Earth, and our whole solar system. And ultimately, it will contribute to our search for life-sustaining properties beyond our own planet.
Artemis 4 will be our first crewed mission to Gateway, our lunar orbiting space station. The mission will install a second habitation element called the International Habitation Module, or IHAB. Lunar IHAB is provided by ESA, but with significant hardware contributions from JAXA. And it's one of our 4 Gateway modules where astronauts will live and work as they orbit the moon. While 2 Artemis 4 crew members stay at Gateway to continue setup and conduct research and monitor ground activities, the other pair will enter the Starship human landing system, which will have already launched separately, and disembark to the lunar surface for science and exploration activities. The larger and more powerful version of the Space Launch System rocket, known as Block 1B, as well as the Mobile Launcher 2, are also set to debut for the Artemis 4 mission. Gateway, the first space station in lunar orbit, will have already taken shape prior to the Artemis 4 mission. Its first 2 modules, the Power and Propulsion Element, or PPE, and the Habitation and Logistics Outpost, or HALO, will have launched earlier aboard a SpaceX Falcon Heavy rocket to the NRHO orbit. The elements will take about a year to reach NRHO, relying on solar electric propulsion and the gravity of the Earth-Moon-Sun system to slowly spiral out to their destination. As the powerhouse of Gateway, PPE will generate 60 kilowatts of electrical power for Gateway's subsystems and its solar electric propulsion system to keep the station in orbit around the moon. PPE will also provide for high data rate communications between the station, lunar surface, and Earth. Several scientific payloads will also take off with PPE and HALO and collect scientific data while en route to the moon.
What we learn from the science experiments and the environmental monitors on crewed and uncrewed missions will make long-duration deep space travel for humans feasible and safe. Space weather is a primary risk to human health and mission success during travels farther away from Earth and the protection of our magnetosphere. For example, the first instruments that have been selected to fly on the Gateway Lunar Space Station focus on radiation monitoring and space weather. And we're very proud to be partnering with ESA and with JAXA to protect our future astronauts. Exploration of the moon will also enable investigations related to our sun, including studies of the historical record of solar activity as preserved in the lunar soil, also of Earth's magnetosphere and of the current radiation environment that can lead to developing and the ability to predict the sun-induced radiation environment experienced by astronauts exploring the moon, Mars, and even beyond.
Artemis 5 will be NASA's 4th crewed mission under the Artemis campaign. The mission will also demonstrate the capabilities of a second human landing system, Blue Origin's Blue Moon Lander, and it will also have a lunar terrain vehicle. In addition, the ESA provided Esprit refueling module and the Canadian Space Agency's Canadarm3 robotic arm will be added to Gateway on that mission.
Diversity of samples is highly prized amongst planetary scientists. And you can see here the increase in volume of samples and the range of locations where the samples were collected during the Apollo missions. It is clear that access to a lunar rover will greatly expand our ability to acquire diverse samples from the areas that we're most interested in. So the Artemis lunar terrain vehicle will have even more capability to gather, transport, and protect samples, leveraging remote operations to continue working in between crewed periods.
Beyond Artemis 5, future missions will expand our ability to explore, conduct science, and live and work on the lunar surface. We currently have hardware in production through Artemis 9. Additionally, NASA has contracted SpaceX and Blue Origin to develop cargo versions of their human lunar lander as an option under the existing contracts. These cargo variants are expected to land 12 to 15 metric tons of payload and be in service no earlier than Artemis 7 mission. In April, the United States was proud to be part of the historic announcement for cooperation between our 2 countries, in which you will design, develop, and operate a pressurized rover for crewed and uncrewed exploration of the moon, and NASA will launch and deliver the rover and provide 2 opportunities for Japanese astronauts to travel to the lunar surface. This momentous agreement was highlighted by President Biden and Prime Minister Kishida and is an example of the strong relationship between the United States and Japan. The enclosed and pressurized rover will be able to accommodate 2 astronauts to the lunar surface for 30 days and will have a lifespan of about 10 years, enabling it to be used for multiple missions. It will enable longer duration expeditions so that astronauts can conduct more moonwalks and perform more science in geographically diverse areas in and around the lunar South Pole. Outfitted with robotics, cameras, sensors, and scientific instruments, the pressurized rover will be a mobile laboratory for exploration activities across large areas of the lunar surface during both crewed and uncrewed missions. It can also be operated remotely, allowing for positioning it at the next crew landing site and enabling science research between crewed missions.
Yes, as Kathy said, we anticipate a big expansion in our in-situ science capabilities with the addition of the pressurized rover. It will allow astronauts to actually examine the samples in a shirt-sleeve environment while still on the moon. And that, of course, will help us to select the most scientifically significant materials to return to Earth for further analysis. And the ability to observe the environment, make critical decisions in real time, and then navigate to new locations farther from the landing site will further refine the curation of samples that we're interested in collecting and the lunar geology that we're interested in observing.
So how have we come to this point? How do we determine what instruments we're making for this campaign of deep space exploration and what investments we're making as an agency? The answer is our architecture. NASA's Moon to Mars architecture is not a mission, it's not a manifest or a set of requirements. Instead, it's a blueprint that defines and ties together the elements needed for long-term human-led scientific discovery in deep space. We are beginning to define opportunities for new programs and projects that close our capability gaps. As we've demonstrated throughout today's presentation, partnerships with collaborators like Japan are key to the success of our Moon to Mars architecture and to human exploration in general of deep space. NASA is interested in international cooperation on every scale. We have partnerships that span from CubeSats to gateway elements to pressurized crew rovers on the moon, all with a purpose of furthering our Moon to Mars objectives. In fact, international collaboration is recurring tenet number 1 in NASA's Moon to Mars objectives. Because space exploration is such an immense undertaking, we know we cannot do it alone. Today, there are multiple ways that international partners can cooperate with NASA as we return to the moon and eventually travel on to Mars. Research, technology development, partnering with U.S. industry and academia, and the provision of elements or capabilities to the Moon to Mars architecture. As we proceed through these architectural segments, we seek to fill gaps in the architecture, identifying and realizing the needed technologies and capabilities for human exploration. Human lunar return will see the first footprints on the lunar surface since Apollo. Foundational exploration will see enhanced lunar mobility and enhanced science opportunities. Sustained lunar evolution will see humanity maintain a long-term presence on the moon, conducting more advanced science and growing a lunar economy. Humans to Mars will establish human presence and initial utilization of Mars. Using a systems engineering process and identifying the priority decisions for developing an initial humans to Mars, our engineering teams have identified the different priority decisions that need to be made. These decisions have the most impact on Mars architecture or need to be made early in order for us to allow the necessary technology development to send humans to Mars. At our 2023 Architecture Concept Review in November, we debuted the first 7 of those decisions. Since then, teams have been performing trade studies to help us make the most informed decisions possible.
NASA has done and is still doing a lot of great scientific work on the past and with our current robotic Mars missions. Just as with the moon, a complementary campaign of robotic and human missions is, of course, the best strategy to study and understand another planetary body. Our robotic missions are providing new topographic, geological, and chemical information to help us prepare for human explorers to land on the red planet and to explore it safely. The addition of astronauts will make use of all that work and move our understanding of Mars forward by leaps and bounds. We're pleased to partner with Japan on the Martian Moons Explorer mission, and understanding the origins and the evolution process of Mars and its moons will provide new context for our own planet's humanity.
Whether our destination is the moon or Mars, we explore for the benefit of all. In turn, we need all of humanity's support to realize this new campaign of crewed deep space exploration. Our colleagues at JAXA are already deeply embedded in our exploration architecture. But it can't hurt to mention that we have several ways for more partners to engage with NASA's architecture efforts at the QR codes on the screen.
The NASA science community is very grateful for the work we've been able to do in partnership with JAXA and the international science community. We foresee so much new opportunity in the future to collaborate on science work across all disciplines through Artemis and NASA's Moon to Mars plans. I encourage you all to take advantage of these resources so you can see where your area of interest intersects with our plans. And as always, please do NASA science.
I hope you'll agree that we live in an extremely exciting time for human spaceflight. Artemis is different than anything humanity has ever done before. The Artemis campaign will bring the world along for this historic journey, forever changing humanity's perspective of our place in the universe. This is the start of the lunar ecosystem, where we'll do more science than we ever could dream of. This is our opportunity to test and refine our technologies. This is our opportunity to learn how to explore the moon and eventually go to Mars. It will be challenging, but it is so worth it. Thank you for the time today.
Thank you very much. What a nice co-presentation. I have never seen two associate administrators presenting this together, and this was such a great opportunity for us to hear here in Japan too. So thank you very much. So next we'll be moving on to the presenters from JAXA, speaking about JAXA's plans and also the roles to play in the Artemis program. So 日本語でここからは進めたいと思いますので。
So now I would like to switch into English. So if you need, please get your earphone ready. Now they will talk about the entire plans for the Artemis and the roles that JAXA will play, and also other missions. So let us start with Vice President Matsuura.
First of all, thank you for wonderful presentation. Now our turn.
はい、ではここから日本語で
Now I would like to switch into Japanese. First, I will talk about our measures, our efforts on the exploration. And I think all the things that I planned to talk were said by Mr. Yamakawa and others, but I would just like to give a review. First of all, before I talk about the explorations, I would just briefly like to look back the history. In 1960, since the first successful spaceflight in the 1960s, humanity has expanded its sphere of activity, and also there was Apollo. And then there was the activities of the space shuttle, and then in the lower orbit, long-term stay has started. So you can see that every 20 years, humanity has expanded sphere of activity within every 20 years. And now, 2020s, we are yet to make a long stay in the moon, but we are seeing a large number of the missions, including those from the private sectors. And now for the international exploration, in 2018, International Space Exploration Forum 2 was organized in Japan in 2018. And this was a catalyst for discussions in Japan about participation in international space explorations. And in 2020, Japan signed the Artemis Accords. And then we signed an implementing agreement regarding participation in the Gateway and also the provision of manned pressurized lunar rover. And we are still at the starting point, but being able to stand at this standing point is because of all the technology and the teamwork that we have shown. And I think we are being trusted right now because of all these achievements. Now, I would like to talk about the image of the roadmap. The activities of the human will expand, and this is what it shows in the ISS or the Kibo, and also Konotori, and also various planetary explorations. We have accumulated a large number of technology, and we will utilize that. First of all, to the moon, from the unmanned exploration, and next to the manned, we are thinking about going beyond. And it starts with the Mars starts with the unmanned, and then we would like to send a mission to get the sample return. And I would like to talk about some of the major projects that we have had, and they may overlap with the past presentations, but JAXA right now, together with the European countries and Canada and the United States, we are taking part in creating the rovers, just as Dr. Nikki explained. JAXA, utilizing all the technology and experiences in Kibo and ISS, we are trying to provide the supplies as well as the space to stay. And also, one Japanese astronaut is planned to stay there. And for the moon, for the unmanned exploration lunar surface, already this has been touched upon, but the very accurate landing by the SLIM is something that is still fresh to our memory. And I think Mr. Kuninaga is going to talk about this later on, so I will just skip it. And on the right-hand side, the Lubex. This is an unmanned rover. On the right-hand, the southern part of the moon, this will go to search for the water and also the value of its utilization. So SLIM and LUPEX, this will be taken up at the session 3 of today's symposium. So please wait for that. And for the manned rover or exploration, we have already heard about this again. But this rover, unlike the previous rovers, we don't need to wear the spacesuit like this, and we can just explore the lunar surface. And this kind of thing is just first for the humanity, entire humanity, as well as, of course, to Japan. But having this rover, well, I think having this rover makes a big difference. So this is expected to play a very big role in the space exploration. And again, I'm repeating, but in April, between MEXT and NASA, the implementation agreement was signed. And not just the use of the Japanese rovers, but it was decided that the 2 Japanese astronauts will go to the moon. So the Japanese astronauts that we know could be stepping on the moon for the first time, and I believe that such image will surely make us excited. And about this rover, you'll be able to listen to the details in the session 2 of the symposium. And Mars, of course, this is also in our sight. JAXA, Hayabusa, and Hayabusa 2 accumulated the technology of sample return from the asteroid. And so we are planning to have sample return from Phobos, and that's titled MMX, and that's planned for 2026. So there are many projects towards the Moon and also Mars, and not just to the projects, but promoting the space exploration, Japanese government and space institutions and academia, and also the Japanese private companies, their cooperation and support is quite indispensable. And so those companies that have been involved in the space development, and not just them, of course we need them, but we also need to have new partners and friends. Together with many organizations or with the organization in various areas, we would like to make joint research and make some evolution, and also return the values to the society on the ground. So we are hoping to create a new innovation, and this will be dealt deeper in the session 4, the symposium later. So I talked about the JAXA's efforts on the space exploration, and in this symposium, I hope that we'll be able to share some of them. Thank you very much.
Thank you very much. And today from NASA, we have Catherine Corner and then Nikki Fox. As mentioned, there's a plan, and the science should be in combination. And today, this is what the Matsuda, and then we have a talk on the science by Mr. Kuninaka. Thank you. From the science viewpoint, I'd like to share some talk on the support. The first page is the snapshot of my presentation. Looking at the bottom part from the Earth, you can see the arrow to the lunar surface. And this shows the lunar activities. And then it contains Kaguya and then SLIM and pressurized rover. And in the middle, the arrow shows the space station is now serving as the base for human activities. And then that would bring to the lunar orbit, which is the gateway. And then on the lunar activities, lunar service activities, and then there is another branch moving towards the Mars. This is the MMX program, and the sample return from the Mars. So this is the overview that we are having in our plan, and they would like to support these activities from science. And Hayabusa, which was launched in 2003, and then it returned in 2020, received a sample. And the Hayabusa 2 also took the sample from Ryugu and then came back to Japan. And in 2007, the Kaguya was launched, which is the observation satellite to conduct the observation on the lunar surface. And then by analyzing the data, we were able to understand what is located where. And then we have chosen some specific areas of interest where the SLIM has landed with the pinpoint landing, particularly in the area of the interests, mostly slope areas. And then it was successfully landed on the lunar surface with the pinpoint manner. And another point that I want to draw your attention are the two robots, REV-1 and the REV-2. These two robots were sent to the lunar surface, and then these two robots were able to communicate with each other and then collect the data and then send back to the Earth directly without going through the bus. So with these smaller robots in many quantities, to move around in the different parts of the lunar surface so that we should be able to gain a lot of data and information. So that is the method that we want to focus on, deploying the small robots in large number, and then gain as much information and then data. So that's the first demonstration that the Rev 1 and Rev 2 made successfully. And then with that, we were able to observe the rocks around, and then mantle materials, that is the Olivian, is able to be observed successfully. This is what I have heard from the scientists. So by so doing, we should be able to have better understanding of the physiology of the moon. And then as the lunar surface science includes the observation from the lunar surface and the sample return from the moon, and then also moon seismometer network. As for the use of the CubeSat, we had a major programs, and then there are payload under the Artemis 1 mission, the Omotenashi and the Eclipse CubeSats, and particularly the Eclipse, for the 6 months, it was able to achieve the activities. And by utilizing these CubeSats, we also like to make great contributions to the science. So this is one of the focused area in our activities. And as mentioned earlier, this is Artemis 3 mission. A lunar dielectric analyzer, or LDA, will be flown onto the moon. So this is a kind of a packaged instrument, and we would like to continue to develop such instruments. And then beyond Artemis 3, we like to propose on a timely manner our science and then the instruments as payloads. As for MMX, this is the global collaboration project. And then now the development of the flight model is being done, and the NASA, the neutron spectrometer and the pneumatic samplers are already provided by NASA. And then currently we are conducting various development activities. And beyond MMX, we also conduct various investment in technology. On the right, the left bottom shows the smaller rover, unmanned exploration, and on the right is called inflatable lander. It uses gas as a fuel, as if it blow the balloon to fly in the atmosphere, and then would land on the surface of the Mars. So this is a new technology for landing on the Mars. And then this is the last slide. I like to emphasize the planetary protection, particularly in order for us to land on the Mars. There is a possibility of life on the Mars. And if we send an explorer from the Earth, that may bring some contamination onto the Mars. Therefore, in order to for the human to land on the Mars, we have to sterilize all the instruments, and then to be strictly under control. And if we put some instruments on the Explorer to be sent to the Mars, we have to create the list of items for storage. This is to protect the Mars and then other planets. Therefore, to take the opportunities of MMX, this technology should be obtained. We are doing very detailed preparations in order for us to send astronauts onto the moon. Thank you very much.
Thank you very much. So I said that there are three purposes for this session: the overview, the milestone, and the strategy of Japan. I think we covered all of them. So this comes to the end of this session. But what kind of a cooperation could we build, and what will be the next step? I would just like to briefly ask about that. And how should we take up those challenges? And what are the determination of the people who are taking up those challenges? Again, I will switch to English.
So to conclude this session, that we would like to talk about the future plans, and also you've been involved so much in leading those projects. So we would like to hear about how personally, also you are thinking about those future developments. So please first begin with the future plans, what to add to the presentations, and also possibly how you feel about the developments. So could you please start, Catherine?
Sure, thank you. So the United States, excuse me, the United States and Japan have a rich history of exploration together, from what we did on Space Shuttle to the International Space Station to robotic missions, and now Gateway and the lunar surface with the Pressurized rover. The architecture that we have aligns really closely with the JAXA's architecture for human exploration, and really, to me, that really points to an enduring capability for us to explore together, whether it be for elements in the cislunar environment or on the lunar surface, and certainly everything from major elements all the way down to scientific payloads.
It's always great time to be doing science, and of course we're excited about the opportunity that Artemis gives us. But as Kathy said, we have such a rich history of working together, NASA and JAXA, each one of our science disciplines having really important partnerships and even future partnerships moving forward with biological and physical sciences, and the work that we're doing on the International Space Station right now, with a partnership in Earth science with the Precipitation Measurement Mission, getting critical climate data for us, the joint mission with JAXA, in planetary science, so many. We talked about MMX, which is very exciting. Also a major contribution to our Dragonfly mission coming from JAXA. In astrophysics, partnerships on the Nancy Grace Roman telescope, looking forward to habitable worlds. Of course, we had a great partnership on the XRISM mission, and in heliophysics, looking forward to another solar mission, building on the legacy of Yoko and Hinode with Solar Sea. Partnerships on the moon through our commercial lunar payload system I mentioned. We're always excited to carry international payloads with us to the surface of the moon through that. And as we get our cadence up, we'll be having two landings, we hope, a year. And so much opportunity for more collaboration with JAXA. But it's exciting. There's so much great stuff happening between NASA and JAXA. And I'm really excited and honored to be part of it.
Thank you very much. It is indeed exciting. And thank you very much for sharing the architecture and also the future plans on architecture. So that means architecture is still on the building, and then this cooperation, collaboration, everything will be adding onto the next stage. So that's just really inspiring for us to hear. So thank you very much. So moving on to VP Matsura, please.
Okay. To carry out the exploration, we have bunch of things to do, and I think it's more than ISS, International Space Station. No country, no organization, no company can accomplish that alone. So we must work together. We may each have a different vision or reason, but the goal at hand is the same, I believe. Let's go beyond Earth orbit together, and let's explore something to be humanity together. Thank you.
Please.
日本がその国際宇宙探査
So Japan engaged in the space exploration and taking part in Artemis project. Of course, the major theme will be, or the target is to create an industry of space. And I believe that's one. But speaking about the Japanese capability of Japan's industry or nation, it's really difficult to make this space industry one big theme, because we have to have a recognition, a higher level of recognition from the society, and also we have to have a mass and also cash flow. So I believe that we are still lacking in the maturity to create this. So in that sense, what is going to drive the international space exploration? Well, one certain thing is that it should be supported always by science. So the scientific enthusiasm or the passion, I think that is always here. As I said, the space science has always supported the space activities. And the Artemis project and the international space exploration, if we utilize those opportunities, we can really seize many opportunities. And so also there is an opportunity that we go beyond Moon and go as far as Mars. And that's what I believe. And we should really timely grasp those opportunities and also utilize whatever opportunities we have to go into space. And in order to develop the science, we must raise the recognition of the space. And I think this is going to be a very important driving force in Japan. So as JAXA, we hope that we can make contributions on this. Thank you.
Thank you very much. So that's an excellent comment to add to this panel today, because science, what's behind it, and then why we would like to pursue this project together. And that's really important. And then your presence two together today and two together from JAXA, that will really show the commitment to both the engineering side and architecturing the universes, like, exploration, plus what we have to know about the science and what we would like to know more about science. So this has been an excellent time. Thank you very much for your insights, and also again presenting together. The joint presentation was very, very charming, and that's something that we'll remember. And then from the JAXA side too, thank you for the balanced presentation about like how Japanese a path so far will be contributing to the next stage, and also how science is really eyeing on like what's important for humanities. So thank you very much for all presenters. Please join me again thanking and give a big applause to the four presenters today. Thank you.
皆様ありがとうございました。Thank you very much.
Thank you very much.
また議事進行をお務めいただきました北川さん、どうもありがとうございま
My
した。
thanks also goes to Kitagawa-san, who has been serving as the moderator.
Everyone kindly requested to come forward, please. それでは記念撮影を行ってまいりますので、皆様自席で撮影いただいても大丈夫でございます。
Those who want to take photos or video, just please remain seated.
北川さん、お久しぶり。なしだそうです。はい。Thank you very much, everyone. それでは皆様、今一度大きな拍手をお願いいたします。Thank you very much. それではただいまより
Now we will have a break for about 10 minutes. We will resume the session at 11:30. Restrooms are located outside of this hall. If you go out and go to the right-hand side, thank you.
皆様にご案内申し上げます。あと5分ほどで次のプログラムを開始いたします。YouTube 配信をご視聴の皆様。
We will start a program in about 5 minutes. For those of you joining us from YouTube, we will resume in about 5 minutes. We will be starting shortly.
それでは次のプログラムに参ります。
Now we would like to move on to the next program. So please take your seats. Thank you.
それでは第2部のイントロダクションとして
We would like to have the introduction to part 2.
有人油圧ローバーで広く探査と題し
And
まして
this will be a discussion titled JAXA and NASA Exploration Extended by Crewed Pressurized Rover. So now let me introduce the speakers.
月面有人モビリティプログラム
We have Ms. Laura Kearney, Manager Extravehicular Activity, Human Surface Mobility Program Office, NASA.
そして JAXA からは
And from JAXA, we have Fumiya Tsutsui, Director, Human Spaceflight Technology Directorate, Pressurized Rover Engineering Center. Please come forward. From here on, Mr. Tsutsui will take over as the facilitator for this section. Please use the interpretation device if needed, as part of the program will be in English. Kearney-san and Tsutsui-san, the floor is yours. So nice to meet all of you. My name is Tsutsui from JAXA, and I am in charge of the Pressurized Rover, and I am the head of that center in JAXA. And as we have been talking about this pressurized rover is like a camping car that runs on the lunar surface. And it is a very challenging thing to develop. And I have the honor of having my partner Laura Kearney with us today, with whom we are jointly developing this this item. So we would like to ask Laura about what she does, and then later we would like to have some discussions about this topic. So in part 1, in the first session, I think you were bombarded with a lot of information, so you might be tired. But this session, I would like to do this session as casually as possible. So please bear with us.
Introduce yourself and your organization and the position of pressurized rover among your lunar surface assets you're providing. Yeah.
Good morning. My name is Laura Kearney, and I am the program manager for what we call the EVA and Human Surface Mobility Program at Johnson Space Center. So if you could, I think I am doing the next chart. Okay, so EHP. This is one of the newer programs within the Artemis enterprise. We're about 2 years old. We were established in February of 2022. And we're actually one of 6 Artemis programs. We have the Exploration Ground Systems, which provides the launch facilities down at Kennedy Space Center, the Space Launch System, the big rocket, the Orion spacecraft, the Human Landing System, the Gateway, which you heard about a little bit earlier, and then our program. We call it EHP because it is a very long title. We are basically responsible for the first elements of the surface systems that we'll have on the surface of the moon towards the end of this decade. So that is the EVA spacesuits, EVA tools that the astronauts will use while they are doing their science on the lunar surface, and the rovers, which you heard about in the previous presentation, both the Lunar Terrain Vehicle, which we call the LTV, and the Pressurized Rover. So it's a very exciting program because the earliest stages of the Artemis missions, as you heard from Kathy Kerner this morning, are actually executed on the surface by our program. We are also responsible for integrating the lunar surface systems. So not only integrating the 3 elements within our program, but also across the landing, the Human Landing System, and any of the future surface elements that will become part of the Artemis program. So I was asked to talk to you a little bit about our organizational strategy or organizational structure. I just wanted to make a couple of key points here. Predominantly that the pressurized rover is a fundamental part of our organizational structure.
Down at the bottom row of this org chart, we have what we call our development projects. These are the projects that are actually responsible for making sure that the hardware gets built on time and within budget. So the three boxes that you see there from left to right are the EVA development project, which is responsible for developing the EVA spacesuits, the LTV project, and the pressurized rover project. So Danny Newswander is our project manager, and he has counterparts here within JAXA and is ultimately responsible for delivering the rover. On the second layer of the org chart that you see here, it's what we call our integration offices. And so this is where we do our budgetary planning and our scheduling. But most importantly, for integrating these elements, it's where we have our systems engineering and integration office, our safety and mission assurance office, and then our flight operations, which is responsible for understanding how we are going to operate these assets once they get to the surface of the moon. So I want to talk to you just really briefly about the couple of other elements. You heard a little bit about them already this morning, but the next generation spacesuit for Artemis 3 is being built by Axiom Space. You can see a picture of it here. This is really an advanced spacesuit. We haven't built a new spacesuit in almost 50 years. We had an Apollo generation of spacesuits, and then we had a space shuttle generation of spacesuits. And the space shuttle suits were actually upgraded to support the International Space Station, and we have not built a new spacesuit since then. We have done a lot of work within NASA, within our engineering directorate on technologies to advance spacesuit development, but it's not been until this contract was put in place that a new suit development has really gone full forward. So what is new about this spacesuit? You can see here in the picture that the subject in this suit is actually bending down and kneeling down towards the surface. You would have never seen someone in an Apollo suit be able to do this, even in our space shuttle suits, because you just really don't need mobility like that in microgravity. But there's a lot of mobility in these suits, which will make it easier for the astronauts to be able to perform their work when they get to the lunar surface. It's also very important that these suits cover a wide range of fit so that we can fit very small people to very large people, because again, as you've heard, we're bringing in partners from all over the world, and we want to make sure that we have an adequate fit for all of our astronauts. These new suits are also, there's a lot of new technologies in them that make them regenerable, which means we don't have to bring a lot of our logistics with us. We can actually regenerate on orbit. And then, as you can imagine, things like software avionics have certainly made a lot of progress in the last 40 years. So this contract was awarded in May of 2022, so Axiom has been working for about 2 years, and they completed their preliminary design review back in February. So things are going very well for the new spacesuit. Kathy also mentioned the Lunar Terrain Vehicle. As was mentioned, this is going to really expand our ability to explore the surface and do more science. We are targeting Artemis 5 for the Lunar Terrain Vehicle. It's going to enable us just to move a lot farther away from the lander. A crew member, because they're limited to the consumables in their backpack, really should not be getting farther away from the lander than about 2 kilometers. When they have a rover like this, we anticipate them being able to traverse more like 10 kilometers away from the lander. So they'll be able to cover a lot more surface and do more science. As was mentioned, it will be teleoperated when the crew is not there. So again, we can get science all year long. It will be used to transport small payloads and logistics. And it is also going to be able to provide some video and imagery of landings and do some prospecting for us so that we can choose future landing sites. Like the pressurized rover, we are asking this vehicle to also support a 10-year lifetime on the surface. We just awarded this contract in April, so just a couple of months ago, and you see there on the left-hand side a couple of artists' renditionings. We selected 3 companies, Lunar Outpost, Intuitive Machines, and Venturi Astrolab. So this is a commercial service contract. These three companies are going to be competing over the next year as they go towards the preliminary design review. And then we will be down selecting to one of these three companies in a little more than a year from now. So for the pressurized rover, I probably won't go over this too much more because you've heard quite a bit about it already this morning, but we are targeting the Artemis 7 mission, or the 2031 timeframe, to have the pressurized rover on the surface. Again, habitation for 2 crew, and it allows them to work in a shirt sleeve environment. We're going to end up talking today about some of the challenges that this rover is going to face in the environment that we put it in, but we're expecting it to have about 24 hours of spacewalking EVA capability per week. And like the lunar terrain vehicle, is also teleoperated when the crew is not there, supports a mission up to 10 years, and as was mentioned this morning, super excited that we have the implementing arrangement that was signed in April of 2024. This team has been working really hard on some of the early milestones. We had completed a mission concept review about a year ago. We have started through the system requirements review. We'll be finishing that up this December. And then finally, a little bit again about what this program brings to the table is just making sure all of these elements work together appropriately when they get to the lunar surface. We talk a lot about how we're going to operate them together. We want to make sure that if the crew is far away from the lander, if something goes wrong with either the suit or the lander, we have an operational concept for how we can safely get them back to the surface. So we talk a lot about integrated concept of operations, integrated requirements, integrated hazard analysis, crew survival, and contingency. It's going to be very important that these 3 elements all work together, and we want to make sure we have an integrated test plan in place so that we can verify the systems before they're flown. And then, of course, our mission operations, ultimately ensuring that we have a good, solid foundation for our surface operations. We did hold what we called our lunar surface phase sync review about a month ago. Our intention is to hold that review on about an annual basis. And what that really does is, as the 3 elements are being matured through their design process, we continue to sync together and make sure that they are all coming together into a mission that fulfills the exploration and the science objectives. So that is our program in a nutshell.
Thank you. Thank you very much. Okay, ありがとうございます。Okay.
Thank you very much. So, in the past year or so, we have been in touch with her, and we have been working in harmony, and I really enjoy working with her and her team. And when it comes to this pressurized rover, so we'll talk about the pressurized rover. So speaking of the pressurized rover, in 2006, there was this a forum called the JSEC, called the International Space Exploration Coordination Group, and there is this global exploration roadmap, and they were talking about what kind of assets will be needed for lunar surface exploration, that they had a blueprint for that. And so that is what they were discussing in this JSEC. And in that roadmap, as a lunar surface asset, this crewed pressurized rover was first mentioned. And so initially, this was a concept that was being studied by NASA. And so that was the starting point. And when I saw this the first time, I thought, hey, this is probably something good for Japan to pursue. And I thought we would have a very good opportunity if we were able to go through with this. And now we have come so far, and now we have this agreement between the Japanese and US. And so I think this is a very deeply moving moment for me. So it makes me feel rather emotional to see this at where we stand today. So let us ask Laura.
Aware of your NASA's R&D activity in Johnson, I believe, about the pressurized rover for many years you were doing, and what did you think about when you became our program manager for taking care of this project?
Yes, we have been prototyping a pressurized rover like this for quite some time at Johnson Space Center. And so we use a prototype. We'll have test subjects and crew members come in, and we'll take it out to the desert, actually, which simulates a lunar environment. And we will test it to see how it operates and how the crews utilize it. And that helps us set requirements that we can then hand over to a partner like JAXA so they can actually build it for us. So yes, we've been dabbling in prototype pressurized rovers for quite some time now. When I was asked almost 3 years ago to take this job, I thought, wow, I can't think of anything quite more exciting than that, because there is a lot of effort going into getting us to the surface of the moon. And at the end of the day, the surface systems are where the rubber really meets the road, and the reason we're going in the first place. And so to be asked to lead the surface systems is really an honor for me, and I'm really excited to work with the JAXA team on the pressurized rover.
Thank you. I think, 我々この1年ぐらいですね。
So in about a year or so, in the past year, we have been talking about technological requirements, and we have been discussing intensively in this area with NASA. And I think the system is a very challenging one, and I really feel that. And even going forward, it's still going to be challenging for us. So I wonder how Laura thinks about this.
Is discussing about the system requirement to be defined for the development of the pressurized rover, and then how do you think that what is the difficulty to define the requirements at this moment?
Yeah, we have definitely learned that going to the moon is very hard. I had the ability to work on the Orion program for 7 years, and one of the biggest challenges in these deep space exploration vehicles is mass, and be able to actually get a vehicle of this size off of the Earth and to the moon is really difficult. So we definitely have a mass challenge. You've heard about all of the interest in the pressurized rover, so there are a lot of stakeholder expectations on what this rover should be able to do. And I like to say right now we have about 20 pounds of requirements in a 10-pound bag. And so we have more requirements than we can actually execute right now. We do have hard constraints with the launch vehicle and the lander that will get this pressurized rover to the moon. So we have set mass and volume limits, and to be able to get all of the requirements and the capabilities that are being asked of us into those mass and volume constraints is proving to be quite challenging. And then, of course, being at the lunar South Pole is an environment that no one has, at least for a human class vehicle, operated in yet, and so it's going to actually bring us a lot of challenges as well.
I agree that, and I think we may need to have some compromise for the requirements against the mass constraints or other constraints, and also but I think we need to have some room for some, how to say, evolution of future capability. I mean, some room for the enhancement is necessary, I think. So we would like to pursue for that, for this development, I think. Okay, so next topic is, I think you have many experience about the development of crewed vehicle. I think NASA has many crewed vehicle. Now, I think this is the first time for Japanese people to develop an independent crewed vehicle. This is the first time for us. And then, Loda, do you think, what is a technical thing? What are technical difficulties in front of us, do you think?
Yeah, we have definitely never built a pressurized rover before, no doubt about that. But the great news is that the big functions that we do require in a pressurized rover, we have done that before. We know how to build life support systems. We know how to build habitats. We know how to keep people alive in space. We also have a lot of heritage in planetary rovers. And so it's really a matter of bringing all of those systems together and making them work as an integrated system. So we're going to definitely tap into a lot of expertise within NASA across the different centers, and we will certainly bring that assistance to the JAXA team. Again, we haven't talked too much about operating on the lunar South Pole, but it is the lighting conditions are extraordinarily challenging down there. Thermal conditions are going to be challenging as well. So we're going to be learning as we go. The LTV and the pressurized rover have a lot of the same challenges, and so we ask those teams to do a lot of coordinating with each other as they are learning lessons going forward.
Thank you. 非常にこういろんな技術があって。
So we're talking about a lot of technologies, and we need to solve the technical issues one by one in R&D. So we need to be finding the answers to so many questions, and we can learn a lot in that process. And even in Japan, looking at the traditional Japanese manufacturers, and we're also talking to people from various other fields. So we're asking for expertise from a variety of areas, and so we would like to also compile all these new knowledges.
At the next session, we have young engineers. I think they are in there, and from industries of Japanese. And could you have any message to them for the development of this pressurized rover? It's technically difficult, I think, but yeah, if you have some.
I would just say it's going to be super to have the new young minds on the team. We definitely need people to think innovatively, creatively, outside of the box. Again, we're doing something that has never been done before. I would also say don't be afraid to ask questions, because just because other folks have done these things for 10, 20, 30 years, it doesn't mean we have all of the answers. And so be free to ask questions and inquire and bring your new innovative ideas to the table.
Thank you very much for your messages. 私はこの
So yes, I think I myself, I have been in the Kibo module for the ISS. This is where I started about 30 years ago, and now here I am. So this is my second big project that I am engaged in. So this is something that will be something that I can pass the baton to the next generation. So I hope our succeeding young people will be able to take our baton and enjoy the process as they go forward. So that's my message to them.
That's concluded. This is my presentation, and our talk session is completed. Thanks.
Thank you very much. ローラさん、筒井さん、ありがとうございました。
Tsutoi-san, thank you very much. So we would like to move on to the photo session. One more pictures. Thank you very much. それでは皆様、今一度大きな拍手をお願いいたし
So
ます。
once again, please give them a big round of applause.
ありがとうございました。
Thank you very much.
それでは次の
Now we'd like to move on to the next program. We have to arrange the stage a little bit, so please wait for a while.
お待たせいたしました。
Thank you very much for waiting. Just a moment, please.
ありがとうございます。それでは皆様お待たせいたしました。
Thank you very much for waiting. The second part of this session is Japanese astronauts to the moon. How the pressurized rover will support crewed lunar exploration. So we're going to have a panel discussion. As an indispensable transportation method for the activities on lunar surface, how will the Japanese lunar rover be planned and developed before sent to the moon? This is an extremely interesting session. So, may I introduce the panelists? Please come up on the stage. Mr. Keisuke Sasaki, Toyota Motor Corporation, Advanced R&D and Engineering Company, Advanced Product Development Division, Circular Mobility Development Department, and Ms. Misuzu Haruki, Toyota Motor Corporation, Advanced R&D and Engineering Company, Advanced Product Development Division, Mr. Keisuke Sasaki. Mitsubishi Heavy Industries, Space Utilization Group, Engineering Department, Space Systems Division, Mr. Junya Takeda. Bridgestone Corporation, Elastic Structure Development Section, Tire Research Department 1, Mr. Ryota Nakanishi. JAXA, Human Spaceflight Technology Directorate, Pressurized Rover Engineering Center, Mr. Yuta Sekiya. JAXA, Human Spaceflight Technology Directorate, Astronaut, and Mr. Norishige Kanai. So these are the panelists. And from here, Mr. Kanai will serve as the moderator. Kanai-san, the stage is yours. Thank you very much. So before we start the second part, I'd like to show this video. Thank you very much. It's very dramatic. It's very cool, isn't it? The music and the image, very exciting. And this is the pressurized rover in Japan. So for the part 2, we are going to talk about this pressurized rover. And the panelists are all the engineers that have really taken part in the development. So we'd like to ask about their real feelings, and also if there's any behind the scene story that they can share with us, we appreciate very much. Already, Tsui-san and Laura-san said that it's going to be a very difficult development, but on the other hand, they say that please have fun and you're going to be very excited. So again, I would like to make this session as casual as possible, and it's very good if we can have some humor and some laughter as well. So usually we start out by introducing the panelists, but I would like to give all the responsibility to you. It's not that I feel it tiresome, but that's how it should be. So starting from JAXA, we have Sekiya-san, who is in charge of the development of the pressurized rover. So, including the self-introduction, please explain about what's the pressurized rover. Thank you very much. I am Sekiya from JAXA. Well, I have been engaged in the ISS, the Kibo, and also camera system for the Expo, and also been involved in this pressurized rover. And I think what I'm going to say has already been said, but I would just like to briefly explain about what the pressurized rover is, and then ask about the detailed technology to other panelists. Next page, please. So this pressurized rover, manned pressurized rover, it drives along the lunar surface. So it has both the functions of the residential area and also the mobility. So this is the very first system. And inside there is air, so 2 astronauts can stay here, and they don't need any special space suit or any oxygen, and they can just live here with wearing just normal T-shirts. And of course, they change to this space suit and go out of this rover and make some explorations. And astronauts can stay for a continuous 1 month out of 1 year to stay inside. And then for the rest of the months, this rover will be operating unmanned and make some explorations and also make some sample taking. So this can be operated both manned and unmanned. Now, about the operation, there is a manual operation or driving driven by the astronauts. Also, there is going to be autonomous driving, which this rover will autonomously drive around. So we believe that this is going to drive about 10,000 kilometers in the span of 10 years that we expect this to be operated. Now, about the power source, solar power and lithium-ion, and there are some long nights which last for 2 weeks. In order to survive that, we are going to use the RFG technology, which is the latest one on the renewable cellular battery. So I just explained very briefly about the rover. Thank you very much, Sekiya-san. Now let us move on to Takeda-san of Mitsubishi Heavy Industries. So not just the rover, but Mitsubishi Heavy Industries has been heavily involved, and one of the leading companies in Japan in the space technology, but including the rover. Could you tell us the role that you're playing in this project? Thank you very much. I am Takeda from Mitsubishi Heavy Industries. Ever since I joined the Mitsubishi, I have been working for the Kibo and providing the space experiment devices. And this is CDF, which is operated by Kanai-san, and I was in charge of that. Now, for this pressurized rover, well, you're all specialists here, and I think you're going to explain in detail. But what we do is, this is a very complex system. This is the combination of complex system. For example, one thing may be good for the tires, but not for the rest of the systems. So my job is to have a bird eye view, and together with Toyota, we're trying to choose the optimum thing for the whole project. And also, in going to the space, we are right now thinking about what should be verified, demonstrated on the ground. And also Mitsubishi, well, we have the manned technology on the space, for example, Kibo or Konotori. So the pressurized space, which allows people to survive, and also the gateway. We have been in charge of the technology that provides the supply and air which is needed for the people to live on these spaces. Nice to see you all. Thank you very much. So Sekiya-san, Takeda-san, listening to your stories, we believe that for people to live in the space, we need to have this device which allows people to live, and that's been provided by JAXA and Mitsubishi.
And then we also have engineers from Toyota and then Bridgestone Corporation, which sounds that they may not have any relationship with the space industry, but this pressurized rover is actually vehicle and running on the lunar surface. Therefore, that's the reason why we have Toyota and the Bridgestone participation. So we have Sasaki-san and then Haruki-san from Toyota Motor Corporation. And then, so please just introduce yourself and then talk about your roles and responsibilities in this project. Hello, I am Sasaki from Toyota Motor Corporation. I joined the Toyota in 2009, and I was involved in the development of powertrain, including engine and transmissions. And I was involved particularly the control part. And since 2020, I have been involved in this pressurized rover program. And then particularly focusing on the powertrain, and then the turning or stopping and controlling and so on. Please go on to the next page. Hello, nice to meet you. I am Haruki Misuzu from Toyota Motor Corporation. I joined the company in 2012, the JAXA in 2012. And I was involved in the controlling of the artificial satellites and the re-entry. And in 2019, I left JAXA and joined Toyota Motor Corporation. And I was involved in the projects of the remote parking function. And since 2020, I have been involved in this pressurized rover project, and particularly for the running system of the vehicles. And then here, I'd like to show some of the technologies that Toyota is involved in. As you can see, we have off-road conditions on the lunar surface, and then there are the very fine suns called Regolith, and then the gravity is 1/6 of the Earth. Therefore, by learning various these conditions and environment on the lunar surface, we focused and then integrated Toyota's proprietary technologies and the running technology. As you can see, we conduct various off-road tests, as you see, and then the brown ones are the ones that I have involved, and then the green or blue ones are the Haruki-san's responsibility. On the right, the leftmost side, this is the slope and then uneven the roads. What kind of the steering that you have to have in order to go over the level. You have to press the accelerator, and then after that you have to press the brake. And on the lunar surface, you have a lot of big rocks and so on. So the astronaut has to have that behavior and an action repeatedly. Therefore, autonomous or automated the control and steering is very important. And my team is responsible for these green parts, which are written on the bottom part, for example, on the left-hand side, and going over the rocks. And then when it goes over the rocks, because of the uneven rocks, there is a risk of rollover. Therefore, in order to prevent a rollover, how to move the control is very important. And then my major responsibility lies on the right-hand side. This is the regenerative absorber. As you can imagine that you are driving on the lunar surface, and then there are craters, and you have to run for 8 hours continuously. And therefore, the driver would be encountered a lot of vibrations whenever they go over the rocks, and then that vibration should be absorbed by regenerative absorber. This is my responsibility in this project. Thank you for sharing the information. So the lunar surface is totally different conditions on the Earth's surface. Therefore, the controlling and the steering is very important. As I listen to your story, the astronaut has to make the training like the athlete for the racer. But I just relieved to hear that you are working on this controlling and steering functions. And the tire has that actually direct contact with the lunar surface, and that's the reason why we have the gentleman from Bridgestone, Mr. Nakanishi. So Nakanishi-san, could you briefly introduce yourself and then your role in this project? Thank you for your introduction. I am Nakanishi from Bridgestone. In 2019, I joined Bridgestone. Since then, I have been involved in the technological development of tires, and now I am involved in this project of pressurized rover. On the lunar surface, as you see on the left-hand side, it has very severe conditions, such as high vacuum conditions, and the temperature fluctuates significantly. Therefore, the pneumatic tire, which we used on the Earth's surface, cannot be used. Therefore, what we are trying to develop is the all metal the tire that you can see on the right-hand side. We call it air-free tire. The development of this tire, as mentioned earlier, the lunar surface condition is very special. It cannot be simulated on the Earth's surface. Therefore, as you see on the right bottom, we have the lunar terrace, that is a demonstration field in the Tottori prefecture, like desert conditions, to conduct the durability test and the running test of the tires and collect the data from these experiments. And we also have the simulation to forecast the running performance on the lunar surface. Thank you, Mr. Nakanishi, for sharing your role. And then those who have some knowledge about the pressurized rover may already understand this. This is called a tire, but this is the air-free tire, so there is no air inside the tire. So there is some technical issues and challenges with regard to the development of such air-free tire, and later I may ask questions to them. So first I have ask some simple questions to Toyota and the Bridgestone representatives. In the space is an area that Toyota and the Bridgestone may not have in your business areas. But when you are asked to involve this project, what is your first impression? What is your first thoughts? Could you just share your honest thoughts? First, go to Sasaki-san. To be honest, I got very excited because I like the space and then I like automobiles. That's the reason why I have chosen the Toyota to work for. But space I like very much, so I was very much excited. Haruki-san, you used to work for the JAXA and you changed your career to the Toyota, but you came back again to the space area. What's your thought? When I left JAXA, I thought I would be leaving from the space industry, but I was very much grateful when I first learned about this opportunity, and because I am able to join this project from the space perspective as well, not only from the automobile perspective. And then Nakanishi-san, probably this is not something you didn't expect it at all, but when you are invited to this project, what's your thought about this? Thank you for the question. The space development within the Bridgestone is not our business scope. We didn't have any insights or experience in space. And to be honest, I didn't expect this opportunity to get involved in the space activities. But at the same time, At the college, we call it the thermomechanics. This is the research on the behavior of the interaction of the sand and the physical objects. Therefore, this is an area of my interest. So I was very much pleased to have this opportunity. As I do some research on the lunar surface, I really understand this is a very technical, challenging project, but that would give me a lot of the excitement and motivation. Thank you very much for your thoughts, and it's like something like the engineer should say.
On the other hand, Takeda-san, Sekiya-san, you were already in the space business, but the pressurized rover is sort of like a car, passenger car. But is there something different from what you usually do? Anything you wanted to do, actually? Let's start with Takeda-san. Actually, I found out about this from the net news, and it's like Ushu Kyodai, a manga. And I thought that this was exactly like that, and I expected that this would be something of a remote future, but now it's happening. But I'm so happy because I wanted to be involved in the space industry, and I'm determined to do until the very end. So this is Takeda-san. And Sekiya-san, how about you? Well, yes, thankfully, I have been involved in this from very early stage, and frankly speaking, we didn't have any cool visual or video that you saw, and we didn't have any idea of what would this be like. And we knew that this is going to be very difficult, but we didn't know what would be the challenges and what can we start with. And we didn't know anything to start with. Thank you very much. So in that situation, the R&D is making a gradual progress. And in the session before, the two speakers said that it's going to be very difficult development. And when you bring things, there is an issue of mass and volume because you have to put them on the rockets. And also, the lunar environment is very hard. So the development must be very challenging. That's my idea. And in that situation, I'm sure you have all the challenges, issues in your own capacity. And could you share some of those challenges or difficulties that you're facing with? So I'm sorry, let's start with Sasaki-san once again. Any difficulties that you're facing, anything that you share with us? Thank you very much. Well, Toyota, there are two reasons why we are involved in the space industry. Number one, through the success, we want to contribute to the welfare and happiness of the future human. And we have this ideal of the industry report. And number two, when we acquire the technology, we would like to adopt it to the mobility and also the technology on the ground. And so we will be able to make more contribution to the humanity. And of course, there's a difficulty for us to take part in this new area. One is the quality assurance. And because the space for Toyota, it's quite different from what we have been doing in the development of the passenger cars. It's completely a new technology. So this is not something that we can do in the extension of what we have doing for the cars. So all the technology, well, first we have to really analyze and put them into detail and then reconstitute them so that we can expand it into the space industry. So we want to really build on the strength we have and then combine it with the good quality. And I think that's very important. Thank you very much. So yes, I understand that it's very difficult because you have to create something or some product that has a high quality and workable and operable on the lunar surface. And Nakanishi-san said that when you did the testing at the in test field in Tottori Prefecture, and for you, Nakanishi-san, what is there any challenges that you face in the suspension areas as well? Well, yes. This developing tire for the lunar surface, it's just impossible for us to actually confirm the situation by going to the lunar surface. So the environment of the lunar surface, we want to reproduce that on the Earth, but also it's very impossible. So the actual evaluation will have to be done by simulation. But we are trying to come up with various ideas, and through the experiments, we are trying to evaluate our performances. And we are very much mindful of that. And specifically, I am looking for the tires that is really durable. And so for on the lunar surface, there are sands and there could be rocks. So in that situation, what kind of things should be done? And also on the lunar surface, the gravity is 1/6 of the Earth, but it doesn't mean that if we put everything 1/6, it's okay. So we want to reproduce the lunar environment as much as possible, and that is always a trial and error process. Thank you very much. So I think it's very difficult to do the simulation without knowing anything. But did you get the original data from JAXA, or do you really have to get the original data by yourself? Well, on that, we get all the information or data provided by JAXA. But of course, there are things that is needed beyond that, and those things can be gotten only by going to the lunar surface, and that's impossible. So we're just trying to imagine what this is like and try to make sure that the project is proceeding as possible. So we are always evaluating while we do the development. So I think all the manufacturing companies have their own secret. And I think you are accumulating all the R&D. So Toyota, you have all your R&D and also making preparations. But Haruki-san, any difficulty that you face in the jurisdiction of you? Well, speaking about the difficulty, well, just as like Nakanishi-san said, well, I completely agree with him. The lunar surface environment, we cannot imitate that or reproduce that on ground because very few people have gone there. So we don't know how the shape of the road surface is or how big are the rocks and how many of them are there. And we do have data, but I don't think they are very accurate. So the gravity is 1/6 on the lunar surface. I am in charge of the observer, which makes the driving experience comfortable. But on the usual development on the ground, actually people get on the car and they really experiment themselves and feel whether whether it is comfortable or not. But we cannot do that at all. So we try to come up with the parts which would lead to good final products. Thank you very much. So it leads to the quality and the comfort is really important. And speaking from as a crew member of, I think I'm really hoping that you do a good job. And speaking as an astronaut, the environment within the spacecraft or life-sustaining, I'm very much interested in that. And Mitsubishi, Takeda-san, what are the difficulties or anything, issues that you're facing as a team? I would like to touch upon two things. Now, about the lunar sand, it's just the same. We do not have the samples, and that we have some from the Apollo. And also, we have to really take away the harmful things, but we have so few samples, so it's really difficult to really decide. And another opposite view is the how to think about the weight or heaviness, because in case of the launching, it really impacts the launch. So always we are looking for the smaller things and lighter things, but once you go to the space, you have no weight at all. So the experiment device, we have put more emphasis on the operability rather than the weight or mass. But on the lunar surface, there is a weight. So if it's too heavy, then the astronauts cannot carry. So striking a good balance is very important and difficult. And also it's a little bit different because 1/6 of the gravity. So that is, well, we have to use our own imagination. And we always think that on the ground it's like this and on the space like this. And that's really important.
Thank you. Yeah, the mass is very important. This is very unique to the lunar conditions. So from that perspective, Sekiya-san from JAXA, to other manufacturers, you provide support to various manufacturers. Within that, what your issues and challenges? Thank you. Of course, to JAXA, running on the lunar surface or the running on the ground, we have no experience, so we are now still learning from them. And the team members, including myself, have some experience of working for the experimental module, the keyboard, and as Kanai-san knows, there are batteries and the solar panels and the navigation systems. We don't have our own technology for that. Therefore, of course, we want to develop a vehicle which would run on the lunar surface. But at the same time, that the total system I've never experienced in the development so far. Therefore, at the meeting, of course, we were asked a lot of questions from manufacturers, but actually there are many questions that I cannot answer. Yeah, I understand, because this is Japan's first crewed mission. It's not a spaceship, but a rover. We had a konotori. This is unmanned the transport vehicle, but this is a new challenge to develop a crewed pressurized rover. As I listen to your discussions in JAXA or Mitsubishi Heavy Industry, rather than you are leading this project, but each participants bring their experience and then the skills and expertise from their own specialty. That will bring us to the next topic. I think it's a great segue to the next topic. Then you have collaboration and working together, and then each country may have different workplace culture and so on. That might be very difficult, I believe. And sometimes you get frustrated. So as much as possible, you can share. You don't have to say something that you don't want to disclose, but considering the cross-cultural communications and working together with people from different companies with different culture, is there anything that you always pay attention to? Anything that you can share with the audience today? Okay, so again with Sasaki-san. To be honest, the Toyota motor we first did not understand the common sense of JAXA or the space, and then the vice versa. This is at the beginning. And as we have the close communications in face-to-face communication, and we have been working together for a long time. And particularly, I think is good is that our development, the team welcomed the people from different organizations, such as JAXA, and then we directly show our parts and components that we are producing. And just using PowerPoint alone cannot promote the deeper understanding. But so we have to see the actual products and actual components, and we are all engineers. So the objects or the actual products are the common language that we have, we share. Therefore, we will continue to have close communication, focusing on the actual products on the actual site. Thank you very much. That's a truly engineering perspective. So the manufacturing is the common factor for all of you. And Haruki-san from, again, the Toyota, you know both areas, automotive and then space. So you may be serving as a translator between these two different areas. Anything that you can share on the backside of the screen? Yes, Sasaki-san just explained very clearly, but particularly the space development and the ground development are totally different from each other. And same as the automobile, this is a large-scale development, and then we are the first Karma. Therefore, we have new members from other teams. That's the new attempt within the Toyota Corporation. As Suzuki said, the close communication is very important, and then also the solidarity is also very important. Not just we provide one part by one person, rather we collaborate with each other and creating the synergy effect, and then have shared objectives so that we can better understanding with each other. This is what I feel on the site. Thank you very much. So have a solidarity and a sense of belongings and the shared objective. From the same perspective, I'd like to ask Nakanishi-san to share your thoughts. And you have a great patch on your shoulder. We talked about earlier before we went onto the stage. And this is the team symbol of the Bridgestone for this rover project. So this is to create the sense of oneness, and probably that you have a lot of different team members from different organizations. So this is something to unite the members. And so this is the largest difference from the conventional tire development is that we don't have any data, any knowledge, and insights because we didn't have any experience. When we develop the conventional tire, we can leverage what we have learned from the past experiences. So that's the major difference. And this pressurized rover development, there is no data available. Nobody has tried in the past. Therefore, we have the tire performance, the goals, and then evaluation, and methods, and so on. We have to start from the scratch. We have to work together. So that's the major difference. And with the Toyota, we collaborate for the conventional tire development. And in such opportunities, we have the collaborations in order to optimize the performance between the vehicle and the tire. So that collaboration can be also applied to this project as well as a Team Japan project. And as I mentioned earlier, we are trying to develop the metal tire, the air-free tire. Therefore, we have the collaboration with other manufacturers that supply metal materials or other partners as well. Therefore, as a one team, Team Japan, we bring various expertise from different areas and then try to integrate those expertise and skills. Thank you. To be curious, the metal tire Is there any application other than pressurized rover? This is the Japan's first or the world first? Yeah. As far as we know, the Bridgestone, we have never had experience to develop all metal tire. And of course, within the conventional tire, we use some steel or other metal for reinforcing purposes. But this is our first attempt to develop the total metal tire, which is very much technically challenging, but I'm very much excited and pursue this area. So it sounds very interesting. So everything is the new experience and the new issues and challenges. So, but we see a very positive aspects of this project. Thank you very much. On the other hand, of course, we should not categorize what is space and what is the vehicle, but as kind of a bridging role, the Takeda-san from Mitsubishi Heavy Industry, how you would integrate these different elements into one. That might be the role that Takeda-san has to play in this project. So you might be in a very difficult position to coordinate and integrate the different technology into one. Is there any good areas and ideas that you are using?
I don't know if I am skillful, but because we use different languages, there could be difference in the recognition or understanding. And because we use the technical language in the industry, we use it without really knowing it. And we notice that it's the technical words that we use only after we are pointed out by that. But I'm always trying to be mindful that I work as a bridge. And I would like to cite one example. There's a word ECU. Within Toyota, it's about the control. It's the entire control, and that's the control. But in the space, there are different names for each control. So we didn't know about the ECU. And for the space, it means engine control unit. So when Toyota uses the word ECU, we thought about the engine. So we were really surprised and wondered what he meant. So these are going on, things like that going on very intentionally. So we try to be mindful about the different languages. Thank you very much. Sasaki-san, I think you said at the beginning that you have to have a very meticulous communication. And the important thing is that you have to ask questions, otherwise you will not be moving forward. So JAXA, Sasaki-san, JAXA, I think you are working as a person to be the leader. Now, in the Nihon Bashi's office, I heard that you have a big room. And what is the mechanism of that? What do you do there? Yes, when this project started out, it was during the pandemic, so we didn't have much chance to see each other face to face, although we were talking over internet. Now, but last year in Tokyo, we created a space where the MHI or Toyota or JAXA or Bridgestone people can get together. And so we decided to have a periodical meeting. Of course, it could be really take time to travel, so we do both over the internet. But actually seeing face-to-face and the unofficial chats that we can have will really allow us to have a better understanding of the person. So I think it's really working to make a better team. So face-to-face is a very good keyword. So these days we use telework and we can do the meeting remotely. But I think to meet face-to-face is very important, especially when it comes to the group working together, various groups working together. Now, I wanted to ask more, but now I have been told that I have to end. So one more question. So just developing and creating the rover is not the end of all the projects, but I believe that you have your own ambitions as a company or as an individual. So through the pressurized rover, towards the next time and towards the future, what is the thing that you'd like to realize? So again, let's start with Sasaki-san. Yes, speaking about the next generation, we think about the children. And for children, really love the cars that do the work. For example, firefighting engine. And so just like that, I hope that children would think that they want to drive the pressurized rover and other ones that work in the space. Then probably they will think about what is the technology and what is the motor working. And I hope that they will be engaged in this area so that they will work to improve the lives of the people. So with the children inside, I'm going to work on this pressurized rover. Haruki-san, please. Yes, I'm so happy and I'm just grateful that I'm involved in this project every day. And my biggest dream is that this will be successful. And when we see the pressurized rover really moving around on the lunar surface, and we all get together and be happy, then that's my biggest dream. But that's not the end of it. And my purpose or goal is that we can utilize that technology on the ground. Thank you very much. Nakanishi-san. Well, globally speaking, I think the momentum of the space industry is really going up, and the future where people stay overnight on the lunar surface is really getting nearer. And as a technician, I'm really happy that I am making contribution on the technology side. And Bridgestone, we always say that the tires always carrying the lives. And also in the space industry and space development, we have the astronauts and also people who may, in the future, stay on the lunar surface. And we want to make the technology development which allows them to stay safely on the lunar surface. And my dream future is that people gather on the lunar surface. And in realizing that, I hope that my technology that I have developed would be a part of it. Thank you very much. Takeda-san, please. First of all, my first and foremost dream is to make a successful rover so that the astronauts and other people will be very happy. And I want to have the NASA and other people feel that it was very good that we chose Japan. And also, the lunar surface logistics is something I think we can create, including the Kibo or and Konotori. And also we have this Team Japan. And if we can further work on the space industry development, and in the end, my Artemis dream is that we utilize that and go to the space travel myself. Thank you very much for your personal dream. And Sekiya-san, please, conclusion. Well, I don't think I have my own personal dream, but what I want to do is to just work on what I have right now. And this is going to be a long project, probably 5 years or 10 years. And so people who are coming in after me, I hope that I can, or I hope we work on the important discussions and debates on the technology aspects, and hope that this will serve as the step for the people to eventually go to the space and live there in the future. Well, thank you very much. Well, I wish we had more time, but within the past 45 minutes, we heard a lot. And thank you very much for your participation. And also, I'd like to thank the audience. Thank you very much. Thank you very much to all the panelists. So now we'd like to take a group photo. The panelists, please gather in front of the table. Thank you.
ご来場の皆様は自席にて撮影のご協力を
And people, the audience, please stay in your table or on your chair where you are. But you are free to take photos.
はい、ありがとうございました。ご
Thank you
登壇
very
者の
much.
皆様ありがとうございました。
Panelists, thank you very much. And once again, please give them a big round of applause.
「ありがとうございました。それではこれより13時30分まで
We will take a lunch break until 1:30 Japan time. If you're leaving, please hand in a questionnaire at the reception desk. And also, if you use the simultaneous interpretation receiver, please return that at the reception as well. If you are staying in the afternoon session, you can leave the device on the chair. And those to the online, there is an URL code for the questionnaire, so please make an access to that. And those who are inside, please refrain from eating or drinking in this place. Thank you. So we'll take a lunch break until 1:30.
右側
The toilet is on the right-hand side, and those who want to smoke, there is a place on the second floor. Thank you.
皆様にご案内申し上げます。あと10分ほどで午後のプログラムを開始いたします。13時30分に再開いたしますので、それまでにお席にお戻りください。YouTube 配信をご視聴の皆様、あと10分ほどで再開いたします。午後のプログラムも引き続きご視聴よろしくお願いいたします。 皆様お待たせいたしました。それでは午後のプログラムを
Thank you very much for your patience. We would now like to start the afternoon program. Part 3 of the program will be a panel discussion titled JAXA's Space Exploration Roadmap, Using Technological Heritage to Explore Frontiers. The respective project managers from each section will share with us JAXA's role in Artemis project in a discussion format. Let me now introduce our speakers. First, manager for SLIM, Institute of Space and Astronomical Science, Japan Aerospace Exploration Agency, Shinichiro Sakai. Also from JAXA, project manager for LUPEX, Human Spacecraft Technology Directorate, Dai Aso. And also from JAXA, project manager for Lunar Gateway Habitation Project, Human Spacecraft Technology Directorate, Norihito Tsuji. Also from JAXA, project manager for MMX, JAXA Space Exploration Center, Yasuhiro Kawakatsu. And also from JAXA, Director of JSEC, JAXA Space Exploration Center, Koji Yamanaka. Let us now welcome these 5 speakers to the stage. From here on, the session will be moderated by Mr. Yamanaka. The floor is yours, Yamanaka-san. Hello, everybody. Good afternoon. So my name is Yamanaka. I am the director for JSEC in JAXA. So we all have project managers. We rarely have this kind of a setup, so this is a very rare opportunity to listen to a lot of interesting topics. So let us hear what our respective project managers have to say about this. So I also want to keep my part short so that we can hear most from our project managers. So let us start from whom? From Sakai-san. So thank you very much for this opportunity. So my name is Sakai. I'm the project manager for SLIM. I know many of you know this, but we have had this first pinpoint landing this year in January, and we will talk more about this. So let me first talk about this photograph. So this is a memorable photo for me. Many of you already know, but the very small devices, one was only 2 kilograms. These devices took this a photo, and these were all operated autonomously without receiving any directions from Earth. So they autonomously took this photo. So I've been in this work job for more than 2 decades, and I have experienced several launches of satellites. But it's the first time ever that I was able to see what I sent out to the moon in a photograph. So this is something that really surprised me a lot. And I was so excited, and I look forward to this session. Thank you very much. Okay, now for LUPEX project manager, Aso-san. So I am the project manager for LUPEX. My name is Aso, and thank you for this opportunity. And I have been in JAXA, and before that I was in NASA, and I have been engaged in ISS called the Life Maintenance Glow Box, and also for Konotori, which is a payload delivery spacecraft. So I have been engaged in those projects. And so I am now putting together all of my experience and knowledge from those projects for this new project, LUPEX. So for LUPEX, in order to have a sustainable activity on the lunar surface, we have to have a sustainable setup, and we also need to bring in whatever we need to bring in from Earth. And we want to also know whether we are able to make use of any resources that are available on site at the moon, such as water. And going forward for looking at the human exploration and the future of exploration for humans at the lunar surface. We look at a lot of new technologies, such as mobility technologies, excavation technologies, sample collection, or withstanding lunar nights. So we are collaborating with other international entities, such as the team from India. So I would like to share a lot of stories with you. Well, now going to the GHAB project from Mr. Tsuji, the project manager. So I am the project manager for Gateway Habitation Project GHAB, and my name is Tsuji. So this is this Gateway Habitation facility is like an ISS that is orbiting around the moon. So we have ESA, JAXA, and CSA, and also from the UAE, we have new partners coming. So this is a new project engaging a lot of international partners. So orbiting the lunar is where we are using this NRHO orbit, which is a very long one. And for NASA's element in the 2020s, we will be launching in the mid-2020s. And then from our country, vis-a-vis this Gateway project, we are in charge of life maintenance project, and also the Lunar Gateway Habitation Project is something that is based on the IHAB project, which is provided by our European colleagues. And we are also adding value in the environmental area. And we are looking at controlling and managing the temperature and the humidity, and also looking at the necessary air elements that need to be provided for habitation, so that we will be able to set up a successful habitation element there. So these are technologies that are leading the way in this initiative. So thank you once again for this chance. Thank you. And now lastly, for Mr. Kawakatsu. So everybody else is talking about exploration on a lunar surface, but I am the one person that is talking about Mars. So this Martian Moons exploration, MMX, that is the project manager that I am doing. And MMX is now shooting for 2026 to use the H3 rocket. So that is the goal that we have in mind in terms of our schedule. And MMX has several characteristics. So we first land at the moon called HOGOS, and then we collect the samples. So the sample return mission is the first mission that we have in plan. And by collecting samples, we will be able to know more about how the Martian moons were made. And also in the greater solar system, we will be able to have hints about what kind of environments led to the birth of life, such as water and other elements. And so that is why we are engaged in this mission. Thank you very much. So probably nobody's listening to my self-introduction, but I do have a one-pager as well. Maybe not. Oh, here it is. Yeah, this is my one-pager. So first, I am the JSEC director, but I really would like to thank everybody for setting aside their time today. And I have been engaged for a long time in konotori. And if you see this kind of photograph, it looks really fun and exciting. Yes, that is true at the very last minute, but to get there, we had to go through a lot of burdensome hours. So after overcoming a lot of the difficulties, the last moment is something that you will be able to remember for life, like this. So this is Aso-san that I am hugging. So I am the guy with the back, and you see Aso-san facing this way. But anyway, the four people we have on stage are really fabulous project managers, all of them. So we have a lot of questions that we would like to address to them. So we would like to get started on this. And about the HTV konotori is one thing, but also we have This is, we have like 400 kilometers, but now these project managers are working at a much longer distance. It's like 380,000 kilometers, or for Mars, it's even more further out. So there are a lot of challenges because of this kind of distance and environment. So these are the questions I want to ask you. So maybe starting from the closer part, probably that's not the case, but in order, I would like to ask these questions. So first, from the lunar orbit, there are a lot of challenges that you face. What about the moon orbit? Well, for the environment for the moon, one is the radiation, I think, that I have to mention. Probably all of you face the same challenges as well. But compared to orbiting the Earth, orbiting the moon has a much stronger level of radiation. And so the lifespan of any device or equipment that we use in the lunar environment is much shorter than what we use in the Earth environment. So that is one of the challenges that I have to mention.
Thank you very much. So, Sagawa-san, speaking of environment, slim, this was a landing mission. So what we first think about is the gravity. And I'm often asked that, well, the pinpoint landing, I think it's same as what Hayabusa did, but the gravity is completely different. And in Moon, it's 1/6 of the Earth. So people may think that it's very small, but when you descend things, it's not really small. In case of the elementary school students, it may be no gravity, but in case of the Moon, I think it's going to be the same impact as the Earth. And the SLIM make a last decision that they're going to make landing, and that was 50 meters high and 800 kilometers horizontally. But then they made a full break, and they were resisting, but still they land in 20 minutes. So when we think about the landing, this gravity is a big barrier. And speaking about after the landing, the temperature, well, the Moon is quite different from the Earth. First of all, the daytime and nighttime both very long. They both last for 14 days each. So with the daytime, it's really hard being boiled on the frying pan, and in the nighttime, it's minus 170 degrees, extremely cold environment. So these are quite different from what's going on the Earth. Thank you very much. Yes, that is indeed true. And just by looking at it, I thought so. Aso-san. So on the lunar surface, you'll be, well, moving around. How about that? Well, you said that the extreme weather is of slim in Moon, and the South Pole in the Moon is quite different. It's a little bit different. For example, it's flat. The flat part of the Moon, when we go there, it's almost white night. So the sun is moving around the horizon, and the sun, the part where we get the sunlight is very small. But once we have the landing machine, well, they have this vertical wall as well, and that gets the radiation, so it gets very hot. So the area itself is not really hot during the daytime. But when it comes to the rover, or when it comes to the side of the mountains, it becomes very hot. And also, in the nighttime, it gets very cold. So in the polar, South Polar, it's very dramatic, that the temperature. And also, well, we are going to walk around using the rover. And when we walk around, we got the regolith, and that is flying around, and then they attach to the body of the rover. And because the static electricity has stronger power, so they attach. And so if they attach to solar power, it could affect the power generation. So the change of the temperature and also the attaching regolith, they are very issues very unique to Moon. I see, thank you very much. But that knowledge, yes, I think it's going to be very useful. And I think it's very hard to overcome those difficulties and issues. But as we heard in the morning sessions, those are the things that actually the people involved in the development want to know. So we're going to further right now. Let's go to the Mars. Kawakazu-san. So I think I'm going to a place quite different from the other three, so it's easier to talk. Now, the biggest thing is that we don't know about the environment in Mars. And Mars, the moon, Martian moon Phobos, has said that this is the most important unexplored place. And the explorer of the Mars used to take a photo of that. But of course, there's never been a mission where a rover would make a landing. So we can only guess what is the situation there. For example, in order to take samples, we do the landing. But the things that can see from outside, we don't know whether it's hard or soft unless we touch it. For example, it's like going to the snow mountain. The white thing, we don't know whether it's really a snow or is it an ice. It's just like that. And also, one other thing is the distance, as you said. Within the solar planet, different planet, solar system, we have different planets. And when you do the communication, it takes about 20 minutes. So you get the message and then send back the reply. Then it takes about 30 minutes to and fro. And so that also happens to the exploration of rovers. And that is one thing that we're really mindful about. So the further it goes, the things get more difficult. And sometimes we do the support. And I realized that the light is really slow. I really think that why is light traveling so slow? And it's very rare that we really think the light traveling is so slow. But when we do the business of the exploration, we feel that light is traveling slow. So in any mission, they have technical difficulties. And so what is you going to do about that? I think that's what people want to know. So the system itself, how have you been able to realize the system, build the system, and how are you going to realize in the future? So I think we have to start with Sakai-san. You have successfully made the landing of the SLIM. Thank you very much. What we wanted to do in SLIM were, I think there were two main things. One is pinpoint landing, that's how we call it. But the conventional landing, they weren't really making an accurate landing within the range of a few kilometers or a few 10 kilometers. That was the conventional landing. So make a landing on the place where it's easy, but we wanted to make a landing where we want to make a landing. So that's why we did this pinpoint landings. And another thing is that, well, we wanted to make the landing machine very small and very light. And we created technology that enables that. And then if we do that, we knew that it will lead to the higher quality. So these were the two things that we were working on as we proceeded with the project. Now, speaking about the pinpoint landing, the key was the imaging process. And the reason why they haven't been able to do the landing was that because they didn't have the image matching navigation system. And people may think that probably you can use the GPS, but unfortunately, only weak communication can be done in the moon. So in case of the SLIM, the SLIM used the took the photo of the surface of the moon with the camera it was installed, and then it recognized and then made a comparison with the crater, the image of the crater that they had inside, and then decided that this is the place where they are flying, and then made a decision of the landing. Now, the posture of the landing was slightly different from what we intended, so we were not able to make demonstrations, but we did the two-phased or two-level landing system. And I think we've been able to develop that technology as well. So in further missions, I hope that this will be utilized. Now, about making the vessel light, I think it's very difficult to talk in a very cool manner. But if I have to point out, we try to do something out of the box, something unconventional in order to make the vessel light. For example, when we make the artificial satellite, we have this very firm body, and then we think about what should be installed inside. But in case of SLIM, at the launch, they had a big fuel, so the tank itself is already big. So we thought that probably we don't need any body, and so we can just put everything like all the measuring devices inside the tank, and that led to making the vehicle light.
So you really have to keep trying. Maybe you could take 100 grams here, or maybe you could cut several grams over here, so you do this and that. And then as a result, you have about 200 kilograms as a hardware, and at a launch time, it's only about 700 kilograms. And to the best of our knowledge, in terms of the hardware, when you look at the items that were landed in the moon, I think this is probably one of the lightest ones. And in terms of the hardware, even if it's 1 kilogram, if you have an additional 1 kilogram, that means the fuel that you need will be 3 to 4 times more than before. So how much you can reduce in terms of the hardware, even in the units of 100 milligrams or even in grams, is very important. So this is something that we really tried hard in the development stage. And seen from that kind of perspective, the ORPEX undertaken by Aso-san next to me, initially you think that it is really heavy, but probably you might think that just reducing 100 grams would not mean anything. But what do you think about that? Well, starting from my answer is yes, because when you transport something to the moon, 1 kilogram is about 100 million yen. People say so. So we're not only talking about the rover, but with ISLO, with our Indian colleagues, we are looking at other items as well. And we are competing for a mass reduction. And we are also looking into units of 100 grams each and how much we can reduce. And this spacecraft is something where we only change the electrical system, but even if it's only changing that part of the system for the propulsion system, that means you can somehow save the propulsion fuel just by a little bit. And that is the last resort that we have been talking about. But Lupex has 4 tires. You cannot take away 1 more tire. So that is something you simply cannot do. So that means we have to look for other areas to seek where you can shave off. So that is the difficulty that we are facing. From that regard, MMX, probably the weight of or volume compared to 700 kilograms, I think yours is much bigger in Mars with MMX. But compared to SLIM, probably it is bigger. But what do you think about that? Well, in terms of the load for the lander, we have the hardware and the fuel and the propulsion fuel. And for faraway missions like this one, we do use a lot of fuel. I think that is a common challenge that we face. MMX, we have 4,200 kilograms, and about 1/3 is about for propulsion. And for MMX, we need to also bring back the samples from Mars. So that is another part. We really have to work on the details of the mechanism, and collecting the sample means from where we are to collect the samples. That is the one question, and it's the Martian moon that we are going for the first time, so we have to make a lot of observations, and we need to succeed in only 1 or 2 maybe landings on that moon. So that is another challenge. So this mission of collecting the samples from the Martian moon, that means we need to collect a lot of sample. That means we have to have much more mass volume. And so you really have to think about this as a major factor, and it is a driver that really has a lot of impact on the designing of the spacecraft itself. And if you completely use up the propulsion liquid, then you would throw away less. So this is a 3-phased item like a rocket. So this was a fundamental change that we made during our development time. Thank you. So everybody really has their own problems. I mean, at surface, you think that, you know, your neighbor's pasture looks a lot greener, but it's not the case. So everybody is really working hard on their own project with their unique challenges that they're facing. And looking at this propulsion system, and also we talked about hardware. But Sakai-san, when it comes to the observation equipment, what you have to say about that? Well, for SLIM's mission, achieving a pinpoint landing is one of the major objectives. And since we are landing on the moon surface, after we succeed in landing, we're looking at this multi-band light optical division camera, which is a very special camera. And we are looking at analyzing the composure, the texture of the rocks and stones on the moon surface. So we have also loaded this onto the spacecraft, and SLIM was able to make a landing. And so we're looking at this multiple optical camera. And it's not that we can take a look at any rock piece, but the scientific team wanted to take a look at rocks that must have come from the mantle or the inside of the moon. And that is what motivates that team. And if we are able to secure hints about what the mantle of the moon is made of, then we will have a better idea of what the Earth's mantle is made of, and are there any relationship between these two? And if the moon's mantle is similar to the Earth's mantle, then we can come up with a hypothesis that the moon broke off from the Earth. And if we see something that is completely foreign, then we could probably say that the moon came from elsewhere and not from Earth. So we should be able to really find a lot of new hints about this. So our team is really looking into this, and details of the analysis are taking place right now. Seeing from an engineer's perspective, this is also a very good mission, because this kind of observation is not something that could be achieved by landing on anywhere on Earth. So we have to look at areas or regions of the Earth where we can find rocks that are of mantle origin. So by having this pinpoint landing strategy, we were able to make that landing, and for the first time we were able to really implement this kind of observation. So if you succeed in implementing a pinpoint landing, then you can engage yourself in this kind of specific study. I think this case was a very good way to demonstrate that. And the way we landed was different from what we had thought it should be, but at the end of the day, it worked to our benefit, because we were able to take a lot of new images and new information and data, because we were able to collect more information about the rocks. And we first had the idea of having one rock, but we were able to observe up to 10 rocks. So this is something that really made us happy. And the people in the observation have, for some reason, decided to name each rock with a name of a dog, like a toy poodle or other dog names. So in the observation name, now they're looking at the Kita Inu, or now the next time they're going to take a look at the poodle. So it was first difficult to understand what kind of a mission they were engaged in, and I asked them the reason why they decided to name the dogs' names, and they were able to. They said that they use the dogs' names because it facilitates giving an idea of the size of the rocks, and cats wouldn't work that way. So anyway, we were able to observe these 10 different dogs, and I think we will be able to produce fruitful results. So at first we only thought that we would have one rock at most, but the reason why we thought so is because of the heat that was involved. And the heat continues to go up. Of the 14 days of daytime, and we landed in the morning of the 14 days, and then the temperature continues to go up. And as the temperature rises and until the observing machinery goes into hibernation, we needed to use that time to do the observation. And so the temperature is also a challenging thing, not only during the daytime, but also during the night. But so far, SLIM has been able to overcome 3 lunar nights so far. And this is not something that was already woven into from the initial design, but we were able to produce good results. And this is something that we have not been able to do in the past, and it's only because of SLIM that we were able to do. And now SLIM has succeeded in withstanding the lunar nights, but this is putting a lot of pressure on you. What do you think about that? Yes, we are under a lot of pressure now because we look at the polar region, and I talked about the way the sun ray comes in more directly. So the shadows, and you have to go in and out of the shadows. And of course, we do that kind of observation, and then we make sure that we charge enough into the batteries before coming back into the sunlight.
That's a little bit different from spending overnight. It means that no matter where you go, it's always a night. So the lantern made a landing on the very best place. It's on a little bit higher ground, but still, during the winter time, the night does fall. So that's very difficult. So you have to preserve all the functions. So, and when the night is over, everything has to be 100% healthy and functionable. And when we make the calculation, preserving the heat is really difficult because you cannot allow some of the machine not to get too cold. And if you make it warm, then it means that the fuel is going out. So preserving the heat or temperature is really difficult. So I think 3 days at best. So you make a landing during the summertime and do the observation, and then a very short night would come, like 1 day or 2 days, and we hope that we can overcome them. So when the heat people were working very hard, then suddenly came the news that the SLIM was able to overcome 14 days of night, 14 nights. So that was a big pressure. So when the morning comes, everything has to be just functioning normally, and we have to make sure that. So we're right now working on the radiator. When we're using the observing device, it becomes very hot. So we're trying to have that heat go away. So just like we're wearing a kimono, so the open radiator will close like this so that it will not radiate any heat into the deep space. So that's how we are trying to spend the night. So that's the lunar night. And it lasts for 14 days. But what about Mars, Phobos? Are you making any measures against the night? The Phobos, the Martian moon. Well, it's quite close to the Mars, and it spends 7 hours to make a round. And just like the Mars, Mars itself also makes its own rotation in 7 hours. So the daytime and nighttime. So 3.5 hours of day and 3.5 hours of night. So the night, the so-called night, is 3.5 hours in Mars. And also, we have to make a very difficult selection in the designing. As I said, the entire mass or weight, we really have to be careful in designing the explorer. So we create an explorer that enables to spend the night, and we thought that that would be very nice. But the night is 3.5 hours, and make sure that all the equipment will be functioning normally. Then it means that we have to continue providing the power. And so if we are to do this for 3.5 hours, it's going to be a large amount. And then that means that we'll not be able to do the exploration and cannot do the sample taking. So other choice is to do this sample taking during the daytime. After the daybreak until the sunset. So we want to make sure that all the sample taking will be done during the daytime. And after that, well, we do have nighttime, but it's very short, so we can limit the use of the battery. So that was the conclusion of a design. But of course, there is something to pay. During the 3.5 hours, we have to take this sample taking. And it's not like Hayabusa, which did in one touch. The Ryugu that Hayabusa went, it's much better. So the gravity is better. So speaking from the purpose of a science, from the 2 centimeters of depth and get the 10 grams of the sample, that is a goal. Otherwise, the value of the mission would decrease. So we want to make a landing and make sure that it doesn't hit any rocks or stones. And so we have to have a good space. So we do the landing and make sure that it recognizes the topography and get the sampling place. That's what we have to do. So it's going to be very complex. So how should be done? And so from the ground, we can make instructions by watching each image. Or if we can do that, probably we can deal with any things that we didn't expect. But as I said, it's difficult to make a communication, and it takes 20 minutes just to send a message. So giving the instruction each from the Earth, it's going to be very difficult. So for us, we think about going electric and also autonomous. So with a very small or minimum instructions, we hope that the rover will make all the operations and movements. And if something happens, we hope that the rover makes a decision. And so we talk about the autonomous. This is a key word, and we've really worked hard for that. So why are we having a hard time? And the reason is because human cannot go there. So if human can go there, we don't really have to be worrisome about the communication time. It takes like 15 minutes or 20 minutes one way. And that's not possible in case of the Mars. And we really believe that being able to go there is really good. So that's how we see the gateway of Tsusan. So going autonomous or going electric. So what about the crewed? So in ISS was very close to the Earth, and 24 hours it was watched and monitored by the staff members on the ground. And anything happens, the alarm went on, and they tried to do what, and they tried to think what should be done. But in case of Gateway, there is a time like 1 minute, And this is crude. So if something happens and the oxygen supply stops or has a malfunction, then it means that the crew, well, for them, the sustainable device is chopped. So we need a device that allows all the crew members to survive, and that all the devices would start or resume functioning within a certain amount of time. So our project has the purpose of demonstration. So we want for at least 21 days, we want it to be functionable without any instructions from the ground. And how to do that, this is really what we are thinking right now together with NASA and ESA. And just simply saying that, can we just let the device function? But even though if it leads to some kind of a damage to the crew members, then other measures should be taken, and that's what we are thinking about. For example, there is a device that removes the CO2, and there are two ways to do that. One is, well, for example, that is broken, so NASA provides HALO, and so there is a CO2 removal device by NASA, or also a device provided by ESA, or there are similar devices within the habitant modules. So probably we can complement with each other. If something happens, then we can help with each other. But is it okay that we can just do that unilaterally? Probably we should wait for a little while, so that probably the function is not really operating as usual. But if it's moderatable, probably we should wait. Or there are some oxygen provision device, and there is a bulb, so probably we can use that to provide the oxygen. So anything that we can be done within a module, then that should be done by us. And then if it doesn't break through, then we can probably rely on the neighboring module. So in case of a satellite, there's always a restrictions that we have to do something within yourself. But since this is an international module, probably we can help each other and complement with each other. But in that about setting that we have to be autonomous.
Thank you very much. So we have the 4 project managers. So I wish we had 2 more hours, because I've been working for JAXA for a long time, but these 4 people hardly really will come together on one table because they're all busy people. So this is a very, very precious opportunity, but I was told to start closing the session, and I still have more things I want to ask you. So today we're talking about the Artemis project, so I want to hear your thoughts about international collaboration and what are your thoughts about the Artemis project. And also, as a project manager, any thoughts or comments, anything you want to mention to everybody here? If you have anything you want to say, please feel free to make use of this opportunity one by one. And before we close the session, so starting from Tsuji-san, please. For Artemis project, as I mentioned earlier, we're looking at the Gateway project, and we are looking at a habitational environment, and also the astronauts will be able to use the camera, and we're looking at the pumps, which is pumps of looking at the coolant water, which is like the heart of the system, and also the battery, which is something that have technology that was nurtured in the HTV area. And power supply is something that is also essential to our daily lives. So these are the backbones of what we need for continuous exploration. So given these technologies, we also have to look at regenerative ways, renewable ways of making this even more sustainable without us having to provide air or water from the outside. We want to also look at new technologies that makes it possible. So we want to be able to contribute to these kinds of sustainable activity environments for astronauts. Thank you. Now, Sakai-san. So related to Artemis, starting from the fact, when SLIM project was started, the Artemis plan still was not in existence. So as we were working on SLIM, this Artemis project became more real. And so one thing I would like to mention about this is maybe it's not directly related to Artemis per se, but what we did in SLIM is, when I look back at what we did in SLIM, the place where SLIM landed is right in between two different craters. So it's a very narrow area. And so if you have this pinpoint landing technology, probably this is something that makes things different, because before people would think that you would not be able to land in this kind of narrow area. So there are many areas in the moon where we were not able to reach before. And now, with the right kind of technologies, you will from here now on be able to reach those areas. So that is one way we can contribute to the Artemis project, through these kind of new technologies that we have nurtured. Thank you. Now, Aso-san, please. Well, LUPEX is also providing data to the Artemis project, and specifically speaking, we're looking at the selection of landing points and the analysis thereof. And after the landing, we also provide data on water resources. And so that is something that we will be sharing with the United States. And we also, and they also have a lot data on water resources. So by sharing this kind of information, we shall be able to have a greater picture of the allocation of water resources on the moon, on a greater picture. And so that way we will be able to directly contribute to the Artemis project. And in the near future with Artemis 3 and 4 and 5, but a little bit further out, when we look at constructing the base on the lunar surface, where humans will be living continuously on the lunar surface, that means we need to also find a power supply on site, and the solar cells would not just do that job. So you need to also have a facility to generate the power on site. And that way, how much sand you need to gather to create hydrogen, or how much of this or that you need to collect to create oxygen. And so we need to be able to look at ways to contribute to developing new technologies where we will be able to generate new energy on site on the lunar surface. I mean, it's a big challenge for us, and we're also bumping into a lot of challenges right now, but we would like to continue trying and going forward. Well, today, in a limited time, we were able to talk about a lot of things, but the science is the objective of the mission, and we are looking at a lot of deliveries. So this is something that is a mission. The MMX mission is something that comes after Hayabusa and Hayabusa 2. That is the impression that many of you have had. And why am I here today? Just to explain to you that. Why MMX when we're talking about a lunar surface exploration? Let me just share with you 2 points. One is we have the sample return mission. So we're going to Hogos, which is very close to the Mars, and come back to Earth with sample from Hogos. And going to the area very close to Mars, a lot of the countries have engaged in the near regions of the Mars. But going to the Mars area and then coming back to Earth, then in that regard, MMX is the first in the world. And I think sending humans to Mars is the eventual goal after we establish ways to send humans to the moon. So this is a major step forward so that we
will be able to realize for the first time to go to Mars and then bring back samples from Mars. Japan is leading this way. And in the morning, we also talked about the pressurized rover and the technologies, but Mars is way too far out, and sending astronauts to Mars is something that really addresses a lot of questions. How do we do that? What kind of spacecraft? What kind of technologies? So we still need to think much deeper and further out. And one of the topics that we bump into is, which is similar to what Tsuji-san is talking about, and so the gateway, this kind of a space station is something we might need to consider when we are setting up a station on the Martian orbit, or whether we are to have some kind of facility constructed on the Martian surface. We do need to have a blueprint of the overall picture, and the gateway is a driving factor in that consideration. Different from the moon, Mars has two smaller moons, and one of them, Hogos, is very close to Mars. It is about 6,000 kilometers from the surface of Mars. So compared to the Earth's moon, the Hogos is orbiting much closer to the Martian surface. So this can be used as a natural foundation, as a station for Mars observation. And this is one factor that we need to take into consideration when we are planning the blueprint for Martian exploration. But at this point, we have no data or information about Hogos, so we first have to find out about that. So in order to create the framework for Martian exploration, we are working together with with other countries like the United States so that we can move forward in this initiative to realize someday where humans are able to observe Mars and the Martian moons. Thank you. So I am one of the organizers of this symposium, and I wish I could say that under my authority I'm extending this session for 2 more hours, but I cannot say so. But anyway, I do have a lot more things that I would like to have talked about. And even in this morning session, many people talked about the pathway we have taken as a country and how the United States really has a lot of trust in Japan. So this is all thanks to everybody's endeavors and initiatives step by step over a long time. So I know you will continue to indulge in your studies going forward with a lot of passion. So I hope that we will be able to have a brighter future. And thank you very much. Thank you very much to the panelists. Now we would like to go on to the photo taking session. So please come forward. Please stand in front of the tables.
Thank
you very much. So please send them off with a big hand of applause.
Okay,
we will change the layout for the stage, so please just bear with us.
皆様お待たせいたしました。それでは次のプログラムでございます。
Thank you for your waiting. Next program is a special session. A ticket to the moon. Japanese technology going to the moon with Artemis. We will have the panel discussion. I'd like to introduce to you the panelists. So please go up to the stage, panelists. The first, Dr. Tatsuaki Hashimoto, the professor of Department of Spacecraft Engineering of ISAS, JAXA. And then we have Professor Funase from the Department of Interdisciplinary Space Science from ISAS of JAXA. And from University of Tokyo School of Engineer, we have Professor Hideaki Miyamoto. And from the University of Tokyo School of Science, we have Associate Professor Dr. Tomokatsu Morota. So these are the 4 panelists for the special session. The moderator will be Dr. Morota. Over to you, Dr. Morota. Thank you for the introduction. I am the moderator for this special session. My name is Tomokatsu Morota. First, I'd like to explain the objectives of this special session. As you may know, in November 2022, Artemis 1 was launched. That is the official start of Artemis campaign. And in that Artemis program, there are opportunities for lunar activities and then lunar landing. And we as scientists or anybody from the private companies who are looking into the space opportunities, this is a great opportunity or the momentum will be emerging. And as the major milestone, which is the Artemis 1 for the moon, and then Dr. Hashimoto and then Dr. Funase, they developed CubeSats, which are put on Artemis 1 onto the space. And then the Dr. Miyamoto's team developed lunar dialic analyzer, which is selected as payload on the Artemis 3. Artemis 3 is the first crewed mission to the moon. Therefore, astronauts would deploy the Dr. Miyamoto's instrument on the lunar surface. So those professors and doctors have seized these very important opportunities. Therefore, today in this special session, we'd like to ask these doctors to share the opportunities and how they capture these opportunities. We have only 30 minutes, but if it is we go into the lively discussion, can we extend by another 30 minutes? Oh no, we're not allowed to do so. Okay, understand. First, I would like to ask each of the doctors to introduce yourself as well as your project. First. Could you put up the slide on the screen? First, Dr. Hashimoto, over to you. Okay, this is a slide. I am Hashimoto from ISAS of JAXA. This is a proposal, and then put on the Artemis 1, which the project is called Omotenashi. Our catchphrase is that SLS is the world's largest rocket. So with that rocket to launch the world's smallest lunar lander, and this is a very small and 20 by 20 by 30. and we are trying to put that on the lunar surface. And if it is successful, the private sectors or universities or even individuals, if they, as long as they have some fund for that, will be join this project. So this is the demonstration purposes. So it's very small, so that it cannot have the precise control like SLIM. Therefore, we use the solid rocket. And then this is a one-time challenge to put that on the lunar surface, so that there is some error of speed. Therefore, there might be an impact onto the moon, 200 kilometers per hour. That's why we've also developed the shock absorber that can absorb that huge impact. But unfortunately, in the initial stage, on the first day, there was some breakdown of the machine, so we are not able to conduct the experiments on the surface. But the another purpose, that is to conduct the radiation measurement on the route to the Mars, it was successful, and then we believe that we made some small contributions to the program. Thank you. Then next is Dr. Funase. Thank you. Another CubeSat is called Eclipse, and then I led this project. And as you can see here, this is Equilibrium Lunar Earth Point 6U spacecraft. So this is to using the gateway on the lunar surface and demonstrate the fundamental technology to control the orbit. And as you can see, the orbit is very complicated, and in that environment, we conducted experiment, and then when it went through the far side of the Earth, we were able to capture these images. And Eclipse used water as propellant, and then that propelling system used beyond the moon to transit the orbit. This was the first time in the world, and it will also capture the entire image of Earth's plasma sphere. And also we were able to detect space dust in a cislunar space. I'm looking forward to have discussions with all of you. Thank you very much. These two are very much ambitious projects. And next, we'd like to ask Dr. Miyamoto to introduce yourself and your project. I'm Miyamoto from the University of Tokyo. And I developed a system that might be put onto the Artemis 3. But first, let me introduce myself and then my project. And then I was involved in the Hayabusa and Hayabusa 2 and the Kaguya and then other science projects. And I am a scientist and using Explorer to pursue science. In other words, that we have a lot of excellent engineering professors, and then they developed various excellent explorers, and this is what I have used for my scientific activities, particularly on the surface science for the moon, asteroid, and Mars. And then I like to develop the new field of science, which is I name the space resources, and then DUPEX and MMX and these ongoing missions. I am very happy to be part of these projects, and also I proposed LDA, which was selected for Artemis 3 payload. Having said that, it is not yet on the fly. Therefore, as a challenger, I like to continue my effort. Thank you. Okay, let's go into the discussion. First, let me briefly introduce myself also. I myself the same as Miyamoto, together with Miyamoto, Dr. Miyamoto, I was involved many missions with him. And then on the left-hand side is the Kaguya, which was about 17 years ago, and I looked very young at the time. And then on the right side is the Hayabusa 2 team. Together with Dr. Miyamoto, I was involved in this project, and then I'm a part of this planetary exploration programs, and then now we have a increasing number of opportunities under Artemis campaign. So with that perspective, I'd like to ask these three professors who actually captured opportunities and share their stories. We are very much excited to hear the story.
So to start the discussion, I would like to ask all three of you, based on your activities so far, what brought you to be mindful? What made you pay attention to the moon? So starting from you. Well, I am specialized in de-electrization, and what is most interesting in landing is the landing on the lunar surface. And so I have been studying this area a lot, and also the mission of landing on the moon. Since the 1990s, in the 20th century, I have started. So first we had the Selene plan, where we had the Kaguya and the lunar orbit satellite, and then the next step for us was to go for a landing on the moon surface. But this did not end up becoming a project. So, and in that regard, we have this new project called SLIM. So I think part of the dreams came through with the SLIM project coming into place. And then after coming to JAXA, we had Selene 2, which was a project of a mission to have a spacecraft land on the moon. And we were in the middle of the project, and we just had one more step to make before this became a full-fledged project. But there were a lot of changes, including the changes in the administration, both in the United States and in Japan. And due to all these political reasons, everything was not able to be realized. But we still have the members who were in my team. Now part of my former colleagues are in the LUPEX project. But for myself, I have always thought that projects concerning the moon were not really being realized in the way I wanted to. So I have never worked on such a small thing like a CubeSat, but now I really feel that I want to make this happen. So that is why I made the proposal, and here I am. So with Selene A and Selene 2, we also have a lot of memories, and this all led to LUPEX and SLIM, and I think that itself is wonderful. And the kind of equipment that you wanted to deploy on SLIM, and you have been studying a lot about these scientific equipments. So I think these will all be made of use. So now I would like to ask Funase-san. Well, I actually, frankly speaking, was not much interested in the moon. So now you might say, why am I sitting here? But frankly speaking, I was not really interested in the moon. And I was interested in how to launch ultra-small satellites into outer space. And so when I first got engaged in this project, it did not really not catch my attention that much. But then I started thinking, well, maybe this is one opportunity for me to make use of my interests. And if we're able to go to outer space by using this very ultra-small spacecraft, and probably this is something that could provide some value to the Artemis project as a whole too. So that is why I am sitting here. So I urge you to also become more interested in the moon. Yes, when we took photographs of the moon, yes, I was really impressed. And the Artemis plan is something that talks about the moon. And we're also looking at the greater outer space. And the lunar surface is actually an area we can demonstrate a lot of technologies related to that. Well, I am engaged in the area of comparative planetary studies. So we're looking at the individual planets in the solar system. Any of them are very interesting. And so first, when we talk about geology of the Earth's surface, that is one thing I worked on. And then I wrote a book about Venus, and then I wrote a book about a Martian moon. And then I also talked about the moons of the Saturn. So I have been writing a lot of articles on those different individual planets. But anyway, the moon is the celestial body that is closest to the Earth. And looking at it, this is a celestial body where where humanity has made a lot of new and important discoveries, and probably in the future, humans will be reaching out to Mars. So in that regard, the moon is a very important and interesting celestial body for humanity. Yes, I think what you always say is really interesting. And so you're not only looking at the moon, but you are looking at all the other planets, and you are comparing and contrasting, and you have a lot of rich stories to tell about these different planets. So I look forward to your contribution to this session. So now we more or less have an understanding of the backgrounds of these three panelists. So now let us talk about the projects that they are working on and how they relate to the Artemis project. So I want to ask deeper questions. So when it comes to the Artemis project, whether you are able to have your devices deployed on the Artemis project, this is something that we have a lot of competition in the world among different entities. And so we have, like the people sitting here today in the audience, are also interested in grasping an opportunity and taking a leap into the space. And so how did you get involved in making your proposals to Artemis 1 and Artemis 3? And if you can just trace back on what kind of steps you made. So let us start from Hashimoto sensei. Okay, let me talk. Well, if I talk too much about omotenashi, I will be running out of time. No, this one. So it's in this white box, but anyway, first, for the first SLS rocket, NASA told us that there's an opportunity for deployment. I think it was in the end of August in 2015, and the condition was that by early October, if JAXA had any intentions, we wanted to make that voice heard. So in such a short amount of time, we did not have time to ask for public opinions from inside the country. So we worked on it as NASA, as JAXA. And we only had 2 weeks, actually. And in the 2 weeks, we needed to come up with a proposal. And as I said before, I've never worked on this ultra-small satellites, but I have always been engaged in lunar exploration, so there was no way that I would not be making this proposal. So within those 2 weeks, I looked at this from different angles, and I came up with this proposal. So when I made the proposal, I did not really have a lot of confidence that this would become a reality, but I really had to make this bid anyway, so that is why I made the application. And one more thing is, as I put down here, this is a very small device that you can be realized at a relatively low cost. And it's not that any space-related entity would be planning for a long time and working on technical details. But this is something where universities or even the private sector or even affluent individuals will be capable of doing if they have the right technology. So that is why I made this proposal. And so within a very short time, I made this study. So I did not really have a difficult time before this got accepted, but after I got selected, I did face a lot more challenges after that.
I don't believe that you come up with this idea within just 2 weeks. So before that, probably that you have a lot of experiences and then the technology for lunar landing. Yes, I was involved in the various projects for lunar landers in different sizes. Therefore, according to the size, I understand how much would be the speed, and then the liquid, the fuel or solid fuel, which one should be used. Therefore, ISAS is focused on the development of the solid rocket, the fuel rocket. Therefore, we had some insights and experiences. But later on, we realized that the rocket is very much different according to the size. The big one and the small one are totally different. But we had some rocket experts within us, and then also shock absorbing or withstanding the shock. We had an experience of Lunar A plan, which was abolished in the middle. But at that time, we developed various the research activities for withstanding the impact. Therefore, I learned from the professors who are involved in the Lunar A project. Dr. Funase, just within 2 weeks, you came up with this idea. Right. Yeah, the 2 weeks, it is kind of intimidating, the period, because it's too short. But at the same time, I thought it's a great opportunity for me to capture so that I can do what I wanted to do. Therefore, during that 2 weeks, I canceled all the meetings scheduled, and we discussed and then came up with different ideas. And fortunately, and this orbit-controlled mission, which is very important, but at the same time, by chance, we had the authority in the field at ISAS, and then so I talked to him, and then we also discussed what would be the propellants. And then we had another expert who studied the water propellant. So this is fortunate that we have a lot of partners and support within the organization, but it was very much intensive 2 weeks. Yeah, I cannot imagine how busy you were, but you also had a luck as well. Yes. Not just having a passion to go to the moon, probably I didn't see as an opportunity, but I realized, and then so this is the one that I have to definitely capture. Dr. Miyamoto, the selection for the Artemis 3. Yeah, at the time of the Artemis 1, probably you must have experienced, but after that, the JAXA, there is a program for feasibility study. Therefore, I just made a proposal for this scientific observation so that with the funded, we were able to conduct a feasibility study for a year. And then when that feasibility study part ended, there was an international invitation for Artemis 3 payload. And it was told that if you apply for this, And then there was an upper limit of the budget, and then just realized the project that I was given to me was only 1/10. Yeah, probably the size of the project is different. So this is something like to create an independent station near the moon. But anyway, we start the budget. We have to think about what would be feasible. But prior to that, for a 1-year period, we looked at different proposals at a different scale. Therefore, we had the kind of idea what would be the design of the instruments. And then at that time, we had some idea which might fit to the Artemis 3 objective, in which the human astronaut would bring that to the moon and then deploy it. But after that, there are 2 steps, 1 and 2 for proposal. And in step 2, we have to prepare documents in English, over 100 pages, and we have to put the calculation of the budget and then demonstrate the feasibility. So this was a very difficult part. But I have a lot of friends overseas, and so I received a lot of support and help of those people overseas. And then finally, I was very happy that my proposal was selected. Yeah, that's good because you have a lot of human network. At that time, I thought I had an idea also for the Artemis 3, but I eventually decided not to make a proposal for that. And just imagine how difficult you did within just the 2 weeks. Yeah, as Dr. Funase said, that we had very much intense 2 weeks and canceled all the meetings and all the appointments. And we stayed overnight in the lab and then concentrated on the proposal. Okay, but now just looking into the brighter side of your efforts, not just difficult parts. But the next question is that you get the ticket to the Artemis 3, but before that, you have a lot of ideas and made preparations, and eventually you are selected. So what kind of ideas that you put into your proposal? But now I see we have only 3 minutes left, but just give us more time for our discussion. Yeah, any projects, we have to understand the intention of the organizer in order for us to be selected. For example, in the case of Artemis 1, the JAXA's technology or the Japan's technology demonstration, it might not be accepted because if that technology is already available in some other areas of the world, therefore we have to emphasize that a project will make a contribution to all humans, or that would be make a great contribution to the science as a whole. So in order for us to be selected, we have to have that kind of perspective. Thank you. Do you have anything to add? Yes. As Dr. Hashimoto said, I applied a lot of proposals for various programs and selected. So each time I just looked at the intention of the program and the objective of the program. And we, as I mentioned earlier, we are scientists, and so therefore we are focused on the science in our proposals. And probably behind us, there is a trust in the science community in Japan and then JAXA, because JAXA is a trusted organization. So that helped us a lot in our successful bid in the selection. This is a great endorsement. having the JAXA on our backside. Thank you very much for your great comment. Unfortunately, the time is running out. We wanted to spend another hour, but we have to wrap up the session. As we listen to your comments, you have a lot of different interests and a different perspective, but what is common is that you have long-term perspectives and then have a lot of ideas even before you applied these projects. So now I'd like to ask what's next for you, next step. Thank you. I was often asked what's next, but unfortunately, I am reaching the retirement age. Therefore, probably I like to give these opportunities to young scientists, and I like to support them to capture these opportunities. Therefore, by utilizing my experiences and what I have done so far, I have a plan to put them together in the report. So I encourage young people to take on challenge. And Japan's the pathway to the lunar exploration was created Dr. Hashimoto. So then next, Dr. Funase, when I proposed for the Artemis 1, when the gateway is created, that the information, the satellite, how we can utilize that. Therefore, which is just in the initial stage, if that satellite would be deployed into the space from the gateway, that would be the next step.
Thank you very much. So I have a lot of high expectations for Gateway. Now, Dr. Yamamoto. Well, yes, I'm working on Artemis 3, and beyond that, of course, Artemis 3 and LUPEX are all the same, but we have to look at the moon and also to Mars, and looking at the Martian moons as well. So this was all just a dream story before, but now it is becoming more and more of a reality going forward. So the pressurized rover is one thing, and we will be seeing the arrival of many more new technologies. So it's not only with the academia, but we are engaging a lot of more participation from the private sector as well. So I am very, very excited for our future. Yes, thank you very much for your very good comment. Yes, so now we would like to conclude the session. This special session is hereby closing. Thank you very much. Thank you very much, everybody. Now we would like to take a photograph, so please come forward to the front of the table. Thank you very much, gentlemen. So let us send them off with a warm hand of applause. And now we will take a recess of approximately 10 minutes. We will resume at 10 minutes past 3. So please return to your seats by 10 minutes after 3 p.m. And for those of you who are leaving at this point, please do not forget to submit your questionnaires and also to return your simultaneous interpretation receivers. The next program will resume at 3:10. At 3:10. Thank you.
にご案内いたします。あと5分ほどで午後のプログラムを開始いたします。15時10分に再開いたしますので、それまでにお席。
We will begin the next session at 3:10. Those who are watching the YouTube, please wait another 5 minutes.
それでは本日最後のプログラムです。
Now we'd like to begin the last program for today's symposium. That is part 4, or session 4, the toward commercialization on the moon, the moment and then leap. We have panelists for the discussion. I'd like to introduce to you the panelists, and the panelists please come onto the stage. The first, we have Mr. Shingo Akao, CEO of Bold Wave Inc. Mr. Yuki Hanyu, CEO from Integriculture Inc. From Sony Computer Science Laboratories, we have Kyohei Yuamoto, project leader of Sol Project. And we have Mr. Yu Miyazawa, Space Exploration Innovation Hub Center of JAXA. Then we have Mr. Kazuyoshi Kawasaki, Associate Director General of JAXA. So these 5 panelists will join the discussion, and then the moderator will be by Mr. Kawasaki. Over to Kawasaki-san. Thank you very much. This is the last session for today's symposium. And for this session, we'd like to talk about the challenges to the moon. And in the morning session, you have heard about the different projects, and then private companies who wish to participate in these areas. And particularly if you don't have any experience related to space, you don't know how to get involved. Therefore, I'd like to share our effort, which is called Space Exploration Innovation Hub. I am Associate Director General of JAXA. My name is Kawasaki. I am in charge of the Innovation Hub. In 2015, this Space Innovation Hub was established, targeting the lunar surface. And then today you have heard about a lot of stories and then see the photos and the images for a gateway on the lunar orbit. And then many different technologies developed in Earth can be applied after sophistication. And then the rockets and the satellite technologies, there are also other technologies necessary which are not obtained by JAXA. So that's the objective of the Innovation Hub establishment. And there are 2 wheels, as you can see. On the right side is the space technology development that JAXA was working. And then on the right are the other technologies where the private companies have expertise. And today, our panelists here, they are already graduated from the Innovation Hub, which was established in 2015. And the 2 companies have a very expertise in a very special areas. We call it a deep tech. And then another one is to use all the technology to go onto the moon. So first, I'd like to ask panelists to introduce themselves and then their projects. First, Akao-san, thank you for introduction. I am CEO of Bold Wave Inc. And I'd like to share our programs as part of Space Exploration Innovation Hub. We are the Deep Tech, which was born from Tohoku University. And our technology is called kind of a wave, the discovery of the wave phenomena on the board. This is a 3.3 millimeter quartz board, and then applying the high frequency so that the superconductivity is supersonic phenomena is appeared, and then within that space. And the application of this is a sensor. At the beginning, we looked at the semiconductor gas and then measure the contaminator gas, the water, and we developed the water meter, moisture meter. And then there is a project called the CREST project that developed the gas chromatography. And that's the reason why we applied. And in 2020, this industry started using ball source sensor for gas chromatography. And then the Curiosity had already contained the gas chromatography. And then at that time, we were able to develop this one and with 1 kilogram, which used to be about 60 kilogram. And we developed a lot of prototypes. And then eventually we call it the LDC, and then we were able to achieve. At the beginning was the planet exploration, but in the middle of the stage, we have to conduct the environmental monitoring for humans to live and stay. And then we eventually created the SLIF, and then for the and then another project is the space environment monitoring. So with these technologies, and of course the low Earth orbit, but in order for humans to live and stay for long term, probably our technology can make some contributions in the life support and the board wave and the BW, and then this is to invite humans beyond the wave. Thank you. That's all. Thank you, Mr. Akao. Then Mr. Hanyu. Thank you very much. I am Hanyu, CEO of Integrity Culture. What we did is to culture cells to create food, particularly meat, the cultured meat and cultured fish meat. So that's the major activities of the company. And then from childhood, I like space and science and fictions and so on. And in order to create the meat, we have to have a lot of feed and then others, but it is not feasible in the space. So that's the reason that we started this business and then culture the meat. So this is what I pursued, and then this is the video you can find on the YouTube, and 360 degrees. And on the Mars, there would be the factories to culture meats. And of course, there are detailed designs and settings, not just the cell culturing, but also the resource cycling, what we have to do, the effluent and contaminated water, and we need a lot of amino acid to create the meat, and what would be the source of these amino acid. So these are the ideas that we have considered, and this is the plant factories. So we had this idea even in the beginning, and then we thought probably the microalgae would be the important the source for the space. And as I discussed with JAXA, we consider that we realized that would be the promising technologies. And then Tokyo, the Women's University of Medicine is one of the partners. And then as we discussed, one of the doctors here at the beginning, we have the Exploration X program. And then algae and then animal cells are put separately in a separate cell reactors to grow. And then the element can be circulated. So that's the beginning, and that was not ended. And from that, we have joined the Stardust project by the Cabinet Office. And then this is the source of the cultured meat. And then one measure, the concept is now recognized overseas as well. Therefore, we are now going into the detailed phases So with this exploration innovation hub, we developed this concept and then established the global presence in this area. So I'm very much thankful to this program. And we are producing this cultured meat. And so if anybody wanted to have a sell the meat, please contact us.
Thank you very much. Iwamoto-san, please. Yes, I am Iwamoto from Sony Computers Institute. Nice to see you all. Now, the joint research with us and JAXA are a little bit different from the two researchers. We are using the traditional, rather worn-out technology to go out to the space. What we have been looking is to do the laser communication in the space. Right now, the communication it's with the satellites or between the satellites or ground and satellites. And we want to change that to optical. And there are many benefits for that. And what kind of technology were we wanted to use? It's like this. We have optical discs, and this is something that's going to be disappear from you. But actually, there is something very interesting about that. And it's actually really operates the discs in a very accurate way. And so this is something that is attached, and then we're going to extend it and all the way up to the space. And actually, this one has a good level of accuracy. So how to operate this in the space is our challenge. So this project is called SOLIS, and together with JAXA's Innovation Hub, we did this, and we created the prototype, and within about 3 years, we've been able to demonstrate this in the space. Now, with this technology demonstration, this optical discs technology can be utilized for the space and communication, and we've been able to prove that. Now, one thing, we have been able to do this, and some of the merits that I would like to talk about. Now, for us, the on-ground technology and on-ground business, they are very clear to us. But when we think about the new businesses, we wanted to take some risks into the unknown territory. And so the joint research really played an important role for us to make a decision. Now, and also we have been able to have the support from the seed level. And as you can see on the right-hand side, at first we used this optical disc technology. And so we came up with the 3D printers and laser discs. And already we have been able to get the support in this. And so we are really grateful that you've given us the support even at this level. And also, as you can see, in JAXA, they have some accumulated knowledge and experience. And so we were able to absorb them at an earlier stage. So running turned out to be very fast. So within a very short amount of period, we've been able to make a technological demonstration of this optical disc in the space. So that's what we have done. Thank you very much. I'm looking forward to the discussion today. Thank you very much. Miyazawa-san, please. Yes, I am Miyazawa of Innovation Hub. Now, I am in charge of the in JAXA to be a contact point for the Innovation Hub with the private companies, and I am in charge of the energy. So I would like to introduce some of the research or the projects we're working on. We want to build an energy infrastructure system, and we are right now trying to get the innovative technology for that. For example, the solar batteries, and also communication, and energy harvesting, which generates electricity with the difference of the temperature. So all these things, we are working together with the private companies as well as the universities. And specifically, I would like to talk about the two themes. One is the perovskite, the development of perovskite battery, because in order to create an infrastructure of the solar panel, we need to have them, we need to make them smaller and lighter. So the solar battery powers, which are under focus even on the ground as being very light and smaller, we are working to expand this. And another thing is the battery cell. There are things that we cannot, that cannot be 100% supplied by the solar batteries. Well, we need to have this battery cells, and the batteries also probably cannot withstand the temperature in the moon. So we are focusing the all solid batteries, and this can emit energy even in the 100 degrees environment. So these are the things that we are working on to develop them in and be utilized in the space. And we have been able to reach the stage of conducting the space demonstration. And we hope to extend these further so that we can build the infrastructure of the electricity on the moon eventually. Thank you very much. Now this hub, so the final goal is to support the sustainable stay of human on the moon. And in the morning, Kuninaka-san of JAXA said that the space exploration is still not a fully established space industry. So he said that they will start from the space technology. But if we think about 20 years or 30 years ahead, if humans are to be active on this moon eventually, then the construction technology, and also they will talk about the food production factories. So all those things that are needed for the people to survive, all those technology have to be accumulated, and those technology are already on the ground, and we must utilize them. Now, the thing that we are seeing today, so what is the most important thing for us to use in the space in the future? They should be smaller, they should be lighter, and also they should be cheaper in the cost. So these three are very important. If we are to send them to the space, right now it says that it costs about 100 million yen per 1 kilograms. So I think your sensor is the smallest in the world, and Sony-san, your optic communication, this is also the smallest and also a very affordable cost. That is very good. So these two are the success examples. But my question is, what prompted you to make an application to the Innovation Hub? Thank you very much. We start up, as I said, we have a very outstanding technology and bring people or human forward. So we have to, one way is to create a new market. So in that sense, space is a very good example. Even so, in order to be able to operate the company as a startup, we need to have sales. But we need to be a startup. And it's very difficult for the established companies to do this. And the members in the startup, we have Iwaya-san. And so it's a group of people who have a lot of enthusiasm. So one thing, important thing is that we get the fund, which allows us to make a demonstration and also see the goal of a demonstration. Then in that sense, the challenges are so clear, as you said. For example, if humans are to live in the environment, in the pressurized, then everything has to be smaller and lighter. So that's why our sensor really functioned well in that. So by teaming up with JAXA, we've been able to create products and market together, which is advanced than what we have right now. Thank you very much. Hanyu-san? Yes, at the very beginning, what we were doing, well, yes, our vision was to bring what we have to the space in the end. And I think this is true to almost all the startups. But in order for the startups to grow, especially in a very early stage, how should we start? And actually, there are some methods to do. One thing is that we just have to keep on moving. And then if we get some new connections or some discussions or knowledge, then we set that as the next goal. So we just continue that cycle. Effectuation is what it's called. And so that's what we do at the beginning of the startups.
At that time, the JAXA, there is a clearly defined issues, and then there are basic space plan, which is a big picture. Therefore, at the initial stage, the JAXA was a very strong partner from the startup side, and we also talked about the venture capital, but the expertise, and it's very, very important for us to grow at the beginning, not just the fund, but also looking at the contents. Thank you. So that's the startups issues, and you found this open innovation platform. And Iwamoto-san, since you are from Sony, which is a large company, but there is a situation where they wanted to leave. Yeah, there was some difficult time. At that time, the space is a new area for the company, an uncharted area. Therefore, the top management of the Sony, it's very difficult for them to make decisions. Therefore, we saw the opportunities at this open innovation platform, and this is the group of experts, which is JAXA, and then the JAXA decided that this technology is feasible and then promising, and that's how we persuaded our top management. So that's the beginning when we joined this joint project. At the time, we were in a very difficult situation, and then that opportunity gave us a lot of bright pathway. And probably there is a joint proposal with the customer, and then you had the research on the remote operation, the remote control. But by joining the hands with JAXA, the top management have agreed upon your proposal. So the partnering with JAXA, does it make you make it easier for you to explain to your top management? Yes, of course, we need some rational decision making, but we don't have enough information or the insights to make proper decisions. So that's why the JAXA's endorsement or the JAXA's commitment is very much compelling reasons for us to make a decision. Thank you. Yeah, it's correct. And then by partnering with JAXA, and in our instrument also, we are allowed to use the JAXA's logo under the JAXA brand. But unfortunately, just having our hands with JAXA do not bring any advantages for financing, so getting funds, because it's more strict. They would look into the profitability and so on. But if we compete in the existing market, of course, large companies would win, but in the space industries, there is a clearly defined market where we can compete and then also collaborate to create something new. And when you say the joint research, meaning that you have JAXA scientists, JAXA researchers, and then you will work with the companies who never have any experience of space. Any thing that you want to share? Yeah, I myself, I was involved in the satellite development and in others, and then I had a lot of experiences of non-space companies. But after I came to this exploration innovation hub, and I was asked a lot of questions about the history and the development of the space. And so I also review what I knew and then my knowledge, and then that is also learning opportunity for me. I looked into the reasons and the rationale behind certain decisions I made. Thank you very much. Innovation Hub give you the opportunities to network with different organizations. And we talked about Hanyu-san and Akao-san before we started these discussions, and you had the different opportunities to connect with each other. Probably Akao-san remember better than myself. In our case, we have the connection with Dr. Shimizu, who is an expert in this microalgae. And then at the beginning, we discussed why don't we collaborate with each other, but we are very, very early stage, but we are looking where to start. Therefore, we set the earlier goal and then started the project. So just the broader and the vague concept was put into the specific project. And then encounter with Mr. Hanyu, it was before this open innovation platform. And I think the space is the area where something that we create some physical objects. And so in that case, we need prototyping. Therefore, some tech nerds are necessary in that project. So there are some opportunities to meet other tech nerds, and then Mr. Hanyu has get the vision in the space, and then we have the technology at the beginning. So the space area is something that we have to make a steady efforts starting from the prototyping. I think it's idea and the attitude are the same as the JAXA. Yes, right. We have to create something new and physically create. And so the manufacturing skills and expertise is required in this area. We talked about the pressurized rover. This is the integration of the technologies that various Japanese companies have possess. Therefore, in the audience, if you are interested in participating in this kind of a program, just review what technologies that you have within your organization, and you may find some technologies that can be applicable to the space exploration. And not just satellites, but also we are doing various other activities. And probably you should look into your technologies and then identify some connections with lunar activities. And then just as Mr. Hanyu mentioned, there is a connection between the space and then the industry that Hanyu-san was involved. I'd like to also ask some graduate members, what about your business situation? The startup are always in a very difficult situation in terms of the managing the company. So we always discuss what we should do. Having said that, what I want to emphasize is that particularly deep tech startup, our goal is not to become rich. Rather, we want to bring humans or humanity to the next step. And then the space, if we don't do anything, we cannot live, or we cannot even walk in the space. Therefore, we need deep tech. So that's our strategy with this technology, that we like to survive in this area. Yeah, as we just discussed, the startup is always face this or life issue. Therefore, within the short period of time, we have to make quick decisions repeatedly. And in that situation, sometimes, of course, we have to have the long-term viewpoint, 10 years and 20 years, such as space area. So if we have that kind of a long-term goal in 20 years or 10 years ahead, we can identify the issues at our hand right now to solve. Thank you. Our organization, we established a company in the US to do the business, and we have to make, of course, another effort. And in Japan as well, we utilizing the core technology. And then probably last month, we had the press release. And together with the Ministry of Internal Affairs, we have the joint research program for demonstration and utilizing satellite system. And then that would be put into the ISS to have a communication with the ground on the Earth.
And also, we have been invited to join other researchers. So we are trying to brush up our technology and also expand our businesses. Thank you very much. In Iwamoto-san's company, you're also making the communication methods for the spacecrafts, and you're providing us with very affordable price. Thank you very much. Now, listening to you, I think there are some university students in the audience. And some of you may think that you want to take part in the space, but don't know how. And I'm sure some of you have that questions. And for example, Takara Tomi's Torakyu also is an alumni from this innovation hub. And at the beginning, they didn't know whether they should take part, but eventually it was a big success. Now, what I want to say is that no matter what your field of expertise is, or whether you're a STEM student or non-STEM student, if you want to realize the sustainable or sustained state of human in the moon, all the knowledge should be injected. And NASA had a logo that make peace in space, and such ideal is also important. So technology and ideal or vision, all those things should be combined together. So to the private companies, well, do you have any particular advice from the standpoint of the private companies? Well, space. If you're doing the or leading an ordinary life, it's in such a remote place. But a human wants to expand the sphere for the sustainable daily lives, then it's really important. And so that means that everything we do is just directly connected to space. And what you need is a little bit of courage. And if you try that, you're always faced with some challenges. And if you overcome those challenges, then it would lead to the benefit of a entire humanity. And it's not just the technology, but also the spiritual world. And so I think it's very good if we become open. So, and this is a hub. And just like Hubble spoke, I think if we can gather together, I think it's very all right, and you don't have to make any reservations. You can just walk on. I am very happy that I took part in this hub, and I think I said that. So speaking about the culture meet or going to the space, what I felt is that, first of all, the cultured meet or space, it's very important that we have a very big picture, big idea, and also try to fill in the details. And individually, it was very fun. I enjoyed it very much. And also, this is the thing that we all must do. And in fact, so what I found regarding the culture meet is that, first of all, if we are to live in the space, and what happens, people in a confined space, six people in a confined space for a year, well, what is going to happen? So having a healthy human relationship or having a healthy community. So for that, this food, this notion of food is really indispensable. So it has a meaning of more than just nutrition. And if we can intake protein, it means that it doesn't mean that we don't need to eat about the algae, but at some point in time, people will need to eat something that makes them feel that they're eating meat. And so when will people begin to have that feeling, and how should that be solved? So it has given us very clear issues and challenges. And so it really gave a significant contents to our big picture. And so I think taking part in this hub was a very good starting point. When we talked before, you said that the geeks who have technology is very important. So creating things, or the geeks that create things, manufacturing things. So do you think they're important? We can probably, Japan is a little bit declining. Well, this is my example. There was one person who spent a lot of energy into just having the sprinkle of onions, and I thought that was a geek. Speaking from my experience, one thing I can say for sure is that if you have an idea, just do it, just go for it. The technology that we are using is the optical disc, and it's called pick-up lens, and it's a very small one, and it's been hanged by a very thin wire. And if we are to use this in space, you have to carry it on the space, the rocket, and that has to withdraw. Endure all the vibration, and we've never had done the experiment and test, and we were quite sure that this will collapse. So at the very beginning, we put that in the vibration test. Then we found out that it was there was no impact at all, negative impact at all, and just functioned normally, and it was a big surprise. So what I can say is that to the things that you want to use in the space, there are so many things on the ground that we can use in the space as well. And these days, we see the private manufactured products are now being utilized for the space. And so if you have any idea, just try it and just go for it. Then you might be able to feel space a very close place to you. Thank you very much. Miyazawa-san, anything you would like to tell them? Well, the hub, we are inviting a wide range of ideas and visions. So we already have the know-how of the satellites, technology of know-how, but to enable people stay on the planet for a long time and do all the exploration, we still need much more. So if the private companies try to apply to join, then probably we cannot give a cool advice, but we've been able, I think we can provide work, we can work together. And it's not just the end. When the project ends, probably we can think again how those technology can be utilized for further. And so we would like to work together with you as we do go along with the project. So if you have any idea, if you have any interest, please knock the door. Thank you very much. So you talked about the application. So, and we have the request for information, RFI. And we welcome you anytime throughout the year. So if you have any interesting idea, please send us, and we are ready to visit you and talk to you. And if there is anything that seems interesting, that things that we want to use in the space, or if that's being used at ground, we do adopt it. And I'm sorry to say the financial contribution may be very small, but just looking at the private companies that participated, they say that it's been enough. And so this hub center is a place to create things and also to advance the level of the product. So we don't know how it's going to be used 20 years or 30 years from now on, but all the technology that has been created in this hub, if those are adopted in our daily lives, and if the world becomes such a place, then I think it's very nice. For example, the gas chromatography and food. Well, I think this is a very big thing. And if the food created in Japan, used in the moon is used, then I think it's very nice. So I hope that you all utilize this Space Exploration Innovation Hub. And please think that this is an all-Japan team. It's not just the JAXA. Of course, you can do it by yourself. But in that case, if you have any trouble regarding the technology or others, just please knock on our door. So it's a little bit earlier, but we'd like to summarize this session.
So our message is this Space Exploration Innovation Hub in a long period of the cycle of the space exploration. This has come at a very early stage in the phase. And from that, we like to create the technologies which is unique to Japan that can make contributions to the space exploration globally. Therefore, we have a lot of opportunities, and then probably that technology may be applied on the ground, on the Earth. So we want to work together with private companies and then others. So please just feel free to come to us. Thank you. With this, we'd like to conclude the session 4. Thank you very much all for panelists. Now we will have a photo session. Thank you very much. Please give them a big round of applause for the panelists. Thank you. To all the audience, thank you for your time to participate in the JAXA International Space Exploration Symposium 2024. And then those who are watching online, the YouTube, thank you very much for your attention. At the conclusion of the symposium, on behalf of the organizer, Ms. Mayumi Matsumura, the Vice President of JAXA, to make the final remarks.
Thank you very much for staying with us for a full long day. And I think in the morning, maybe I was a bit nervous, but I did not mention my name. I forgot. So once again, my name is Matsuura from JAXA. And today's symposium had actually a Japanese subtitle or a slogan which read, "A new era of dynamic space exploration pioneered by all Japan." And so when we talk about this new dynamic space exploration era, we talk about this new era, and also we talk about deep space as well, not only the moon, but including the other planets such as Mars. This is probably something you might have heard elsewhere, but after listening to all the discussions that took place today, I think there are many other new aspects. We have the shin in Japanese is the meaning for new, but shin is also another word for moving forward or pioneering or propulsion. Also contains the sound shin, which means new in Japanese. So I hope you were able to be quite excited to hear a lot of new or shin stories today. And also we had so many issues and challenges that many people spoke of today. So in any regard, space exploration is not something that can be done in simple way. But we do believe that space exploration is something very much worthwhile, going beyond those challenges, because there is a lot of value. So that is why we should continue to move forward with an all-Japan effort. And I think everybody here in the audience was able to share the thoughts. And thanks again, once again, to all the panelists and all of you who participated online. Thank you very much once again. So we would hereby like to close today's session. Thank you very much once again. Thank you very much. This concludes the JAXA Space Exploration Symposium 2024. Thank you very much for your time today. To all of YouTube viewers, we have provided the URL for our questionnaire. We would appreciate your cooperation so that we can make the most of your feedback for future events. We ask that all attendees here present physically to kindly fill out the questionnaire and return it together with a card case to the registration desk. If you used a simultaneous interpretation receiver, please be sure to return it to the registration desk. To prevent the receivers from being misplaced, your understanding is appreciated. Thank you very much for your cooperation today.
The flight mode is on. Lower電池起動. The thermal batteries have been activated. 全システム準備完了. All systems are go. Main engine start. The main engine ignition. Further BA 点火. Lift off. Solid boosters ignited. Lift off. プリズムスリムを搭載した H2A ロケット47号機は2023年9月7日午前8時42分11秒に種子島宇宙センターから打ち上げられました。We have a liftoff of the H2A launch vehicle number 47 from JAXA 種子島 Space Center at 8:42.
心地いい風がすすき揺らす頃、白い噴煙を巻き上げて、僕らに別れを告げた君を夜空に探した15夜、暗闇明るみすべてを映す瞳のスクリーンの裏側、広い海やドーナツ状の山脈も見せてくれた。君の行く場所、浮かぶ心の中にあの日見た地図、まだ誰もたどったことのない 8日間の眠りの果てにおはようと呼ぶ声が聞こえて、暖かいのは朝日じゃなくて眩しい西日で戸惑った。初めて見たはずの景色は見覚えのある場所ばかりで、近くで見ようと降りていたら体が急に重く感じた。地平線は水平に映せなかったけど君に見せたい。僕がいる場所伝う空気もないのに青い星から声届く。諦めない想い一人じゃなかったよ。背にしたくらい空雄大のメモリー。ワンチャンス掴んだ謎解く鍵。浮かぶ心の中にあの日見た地図。まだ僕しかたどったことのない